In the training guide, what we have here is a couple structures. I'll show you maybe ways to make this a little easier to navigate um, as we go through things. You've got a table of contents that is, if you notice you hover the mouse over stuff, you're going to get a little different, the icon's going to change. This is all, it's hyperlinked to those sections. Now that's no big deal, but just if you want to go to say this point group exercise, just go over there and click on it. It jumps you right to it. Okay. There's not a button on each page that says go back other than whatever's in your PDF viewer that can get you back to it. So what we have here, looking at this in the table of contents, we got a little bit of introductory stuff up front. And you see this, what's on the menu, general versus modular menus. And you can see it's all contained on a single page there. So that's not going through all the commands there. That's just telling you what types of things are on those menus. The general menus are the menus and the commands on them that are available in every one of the Carlson modules, regardless of which one you're in. So if you're in civil, if you're in survey, if you're in mining, if you're in construction, if you're in hydro, it doesn't matter. You always have file, edit, draw, inquiry, settings. Actually, I missed one. That's file, edit, view, draw, inquiry, settings, and points. Huh, I just realized that I missed one in there. I talk about it in the we're in the pages, but I missed it in the table of contents anyway. Then in the modular menus, the menus that follow that points menu are the ones that are specific to a certain module. So the survey module has its own menu starting with the survey menu. The civil module has its own menu starting with the 3D data menu. Okay, so um, and that's where we're going to be doing a bit of our focus these next couple of days. So you can see then we're going to talk about next some settings, and then we're going to get into, after we talk about those, and we're going to be brief on that. What we do in our fundamentals class is we focus really heavily on settings and some of those early tools, the early kind of editing commands and such like that. So we'll get a chance to use those, of course, but we're not going to be able to do a lot of focus on that. That's a 2-day class just to learn the fundamentals of using the software. So we're going to be jumping a bit ahead of the curve there. So, but we will back up and get the idea of surface modeling. Okay. So from that point forward, we're going to start talking about points and when and where and whether to use points. And then we talk about this surface and contours. But what I'm simply pointing out here is when you see an exercise, it will be in red typeface in the contents, and then that's going to jump you straight to, for instance, this point groups exercise right over here on this page. It's going to start you into these little numbered steps of, what you go through, step number 3, and then 4, then 5, and then, back out of that exercise. So those will take you to those things directly. The surface modeling, we're going to be, like I said, looking at that in some depth. But then, and we're not going to necessarily do this, we'll probably get a lot of work here in this. Uh, we're going to go over some of this, um, the theory and stuff behind it here in the surface and contours and terrain modeling and the modeling process. And we'll go through, excuse me, some of these exercises and this break lines and some surface evaluation tools. And then down here is this putting it all together workflow. And I'm going to show you that real quick. I'm going to jump over to it. It's not really going to be part of what we're doing in these short 2 days because it's usually what we conclude the fundamentals class with. So it's a really good review for you at a later date because you have the same data sets that it's asking for in here. And this gives a little example of a drawing you might get in that has some points in it, and how you're going to turn that into, you can see here the stockpile example, and it goes through some different techniques on how to model the stockpile. Um, and then you compute a volume, and then at some point you're going to uh, design a borrow pit out of that stockpile. And then, and here's some of the 3D modeling tools, merge these two surfaces together, some different techniques on how to, uh, how to draw the various contours and parts of that. Then we're going to model in a little roadway design. Now this is done without the civil tools in terms of road design, so it's a very simple, uh, basically taking a center line and placing it. That's this green line here on that, coming into the borrow pit on the stockpile. Putting that into a profile editor, and it's just the generic editor, not with all the road tools. And you can see there's the existing ground. Here's my, start to stop. I've added vertical curves. And then we have a 3D, a profile, and an alignment, which is our 2D. That's our center line. And so we take that to generate a 3D polyline and draw it on the ground. And that's what you see down here. That's that center line. Then we're going to offset it, a certain distance left and right down a particular cross slope, in that case, like a 2% or 2.08% or something, and come up with designing a little access road into our stockpile. And that basically wraps up that whole thing. Now we're going to be looking at, extending that into these civil exercises. We have this single roadway design, what we do with it and how we um, come into it. And so basically the little exercise here is we're going to start with an alignment, how we're going to do that to create using the road design tools, how we're going to generate all of the earthwork. And then we're going to look at some additional like site grading. We've got like a building envelope and a parking lot, and you can even see, um, here's the case for that building. We've got the cut and fill lines, also with the parking lot. So two separate entities. And how do we handle, grading in between um, each situation. So if we're over here on the building pad, we're going to grade it, but we're at the parking lot and it's not at the same elevation, and maybe it's at a downward slope and the building is level. How do we handle that? And so basically that gives us the tool so that we know, and we can go in and look at this stuff before we start building these final surfaces and these final models. We know how exactly what's going on with that, and we know how to exactly fix those things because we can manipulate all of those 3D edges that are going to define our models. Okay. And then we take a look at RoadNet and how that plays um, in your workflow if you're doing road design. Now, and then following that, there's a section here called the general or command reference with the general menus. Now, this is where, as opposed to that, this first idea down here of what's on the menu, where we talk about the general and modular menus, which really just says, okay, here's the draw menu, inquiry, settings, points, that sort of stuff. File, edit. Anyway, wow, actually I missed the whole menu there. I missed view. I don't know. Look what it is. But anyway, so as opposed to that, it's just a generalized approach. What you see here then is in this command reference, that's where you're going to get all of these individual menus and the commands that are on them and what they do. Now, I wanted to show you this to show you a little bit about how this is structured so you can see it as well. When you see something that is boldface and red, like this drawing cleanup, for instance, that's one of the menu commands, if you can see it. Sorry, get over here. So here's that on the drawing cleanup, which is on the file menu. Okay, and there's some other commands here, like I'm trying to get this to, yeah, like save, save as, import, extra. All of these different things are different commands, but they're not bold and red. Here's you're going to see one that's bold and red. And all that means is this, that after, 30 some years of doing this, I have found a couple of commands that are really helpful in the work that I do. All of the commands are important, all of them are helpful, but this one is, one that I have found just through my usage that is something you might want to pay a little extra attention to. It's not that the others are not any good, and it's not that these are the only ones you should use, but just that I found these in of some particular good utility. You may not use them at all. It may be a little slightly different thing that you do, but in general, that's what that's going to indicate. Okay. So you'll see some of them done like that. Now I'm over on the edit menu, and you'll see some are red, some are not. Now, one of the things too to talk about is if you look at these commands, and you can see right here, and I've talked about it, contains both standard CAD editing tools like move, copy, and trim, etc. And then what we call these Carlson enhanced variations. In fact, I had a had a class several years back in survey, and the guy called these Carlsonifications. I said, okay, that's good the early part of the morning, but by the afternoon, nobody's going to be able to say it. And so these Carlsonifications, as he dubbed them, were the Carlson tools. And again, what you're winding up doing when you use one of those commands is you're taking something in the CAD file, or maybe something doesn't exist and you're creating it. But in the end, when you're done with whatever operation you're using, you're left with still a standard CAD entity. It's either a polyline, a point, a piece of text, something. There's nothing special about any of these things that you create, and you can create them any way you choose, whether it's by a standard CAD command or whether you use the Carlsonification of that CAD command to create the object that you're after, or to make the effect, make the change that you're after. Now, all of those things I say, like when you're creating a center line, for instance, all that the CAD system knows about is that you have a polyline in your drawing. It doesn't know it's a center line. It doesn't know or care. It to him, to the CAD system, that could be the trace of a circuit pathway, or it could be the seam on a piece of clothing and patterns or something. It doesn't care. It's just geometry. But Carlson keeps track of all of that through the linking of this drawing data to these external files. You have centerline files, you've got profile files, you've got coordinate files, you've got surface files or tin files. So that's the big difference. And so what we're talking about here on this command reference is when you see these CAD tools like move, copy, trim, and edit, and things that you can certainly legitimately use to create what you're trying to do. And I do not discourage their use at all, but you're going to also see some of these Carlson enhancements that they have programmed in to make it easier for us as surveyors and engineers to understand and use. And because of that, you're going to see in this treatment here, all of those standard commands like undo, redo, erase by select, erase single, erase last. Those kind of things aren't going to be addressed in your book here. We're just going to be talking about the Carlson enhancements to those commands, okay? So if you don't see it there, then it's most likely because it is a standard CAD tool. Those are obviously always available um, um, in the help system. And most people have probably come to be familiar with them at this point already. Okay. So this goes through, excuse me, a bunch of those commands on these different menus, and it's a nice little, essentially, compilation of the, sort of a help system. A lot of these, in fact, come out of that help system, but there's little things like down here is this point object snap, a very handy tool, particularly in the surveying world, where you're dealing with coordinate points, but you might not be dealing with coordinate points. So, um, whether or not to use them is whether that's important to you or not. Okay, and then through points. Now that's your general commands. And then once we're through the points menu, you start this civil module menus. So here's your 3D data menu. And then it goes just like we talked about, through all of the different menus, all of the different um, commands that are there. And some of them, we've got illustrations on certain things as you need them. Okay. So that will basically be the structure of your documentation, of your training guide. Use it, keep it handy as you learn the software. It's not going to be something that you're going to read overnight and just absorb. Now, we'll talk a little bit about some of this stuff to get sort of set the stage. You can read over here, it's getting a little old in the tooth, actually. It's more than 40 years now instead of 30. When did I write this? Back 2016. Okay, so I never really updated this part. But anyway, the key to out of this little paragraph here about me is this line right here. So keep that handy. You've got access to us as we, after we finish the class. So please feel free to stay in touch. Any type of question, even if it's something we didn't cover in class, none of that matters. We can take care of that as long as it's something that, you can't call me up and say, hey, I need you to do this work for me that's going to take me, a month and a half. And we can't work for free, obviously. Nobody can do that, but we can certainly, if clients need it, and we've done this many times, they need a little help on a project, and maybe they want to hire us as a sub-consultant, and that we can work on to something like that. But if it's a general question of the software, even if it takes, an hour or two for me to research and put together a response to it, that's all included with what you got when you became an MSoft client. So don't hesitate. And if it's something that is, you know, going to be too much, at that point I'll say, well, okay, we need to talk about, a proposal and a potential contract. But 9 times out of 10, it's just me answering a question for you. So please keep that handy and use it as you need. Okay. So, and you can read all of these, cutesy little paragraphs and abouts, but a couple of things to notice is some paragraphs, you're going to see these little icons next to in the manual. The one with the eye means it's exclusive to the IntelliCAD platform. With the A, it's the AutoCAD platform. Oh, by the way, what platform do each of you all are you running on? IntelliCAD or on AutoCAD?
I've got CAD Map 3D.
Map 3D, so you're an AutoCAD, okay.
I'm on IntelliCAD.
Okay, and Ryan?
I'm an AutoCAD.
Okay, so two AutoCADs. And two IntelliCADs. Actually, I've got both platforms, so it can run. So if we run into any kind of differences or things that you see as we are going through it, please, interrupt and say, hey, this is different under my platform. I understand it can be, and so, but I may not remember to stop and say, hey, it's different here. So just let me know, and we'll make sure that we get things done, because IntelliCAD has a lot of things that are a lot more efficient that you can get up, like if you're attaching an external reference, or if you're setting a text style, or you're doing, block insertions. All of those things can be done from one very quick interface, and, setting layers and all that kind of stuff. So anyway, so those are things that you may have to do separately, but we're not going to have too many of those. So anyway, you'll see that, and you'll see then, these two guys up here. When you see these, there's a little idea here. It's a tip or a trick, a good idea. And it says not necessarily a requirement, but it's possibly useful. And then here's an important thing that you might want to sort of, get the highlighter out and take a note of. All right. And then we talk about what Carlson software does is basically, and I'm not going to read this to you, but it's basically just a bunch of tools that run on top of this CAD drawing, this sort of unaware program that creates things. It creates, CAD entities. So, it creates circles, lines, points, etc., 3D line strings. And then but the CAD drawing itself is unaware of it being any kind of relationship as an engineering item, like a center line or a profile. And so basically what this is doing is, what Carlson is doing is it's putting all of that intelligence into those things, but it's also intercepting what we, we want to draw a road center line. Okay, well, in AutoCAD speak, we need to draw a polyline, and it needs to have straight pieces and adjoin arcs, preferably keeping the arcs tangent to the incoming pieces of straight lines, and then exiting the arc into another straight line at a point of tangency as well, and string all those things together. Well, you can do all that using the polyline, draw polyline tools in AutoCAD. Um, it's not necessarily all that easy, but you can certainly do it. And it doesn't matter to Carlson whichever way you do create that. But what Carlson is in general, though, is something that sits in between you and that CAD system. And you say, I need a center line. The CAD system says, okay, he needs a polyline. So Carlson jumps in and says, oh, okay, Mr. Engineer or Surveyor, I'm going to ask you questions in terms of engineering and surveying disciplines that you're going to understand better. You give me all the information you've got, and then I'll take it and I'll hand it to the CAD system sort of behind the curtain. You don't have to worry about seeing all that. So that's generally what is going on. It's just a layer in between you and the raw CAD file, the CAD system, that helps you get your work done a lot sooner. Okay, and a lot more readily understood. And then we're going to talk about, and again, we're not going to go over this in depth on how these things are set up and organized in the directory structure. We will talk about it very quickly, just enough to get things moving um, for us. And we're going to really sort of uh, jump in right here on page 18 for these surfaces and contours, is where we're going to really start to pick up what we're going to be talking about. We will, though, first talk about the settings and the things that we need to know and the settings that we need to have either set or unset to, you know, away from the default condition, so that we can understand what might be happening. Okay, so that'll be the first thing we look at is we'll get those settings set up correctly, and then it'll be a point to come at about our mid-morning break, and then after the break, then we're going to jump in and start talking about terrain modeling and what all that's going to entail. Okay, so with that, I'm going to pop over here and load up our Carlson. And again, when I need to, I can switch it over to the AutoCAD version. Let me, I don't need the 2024 version. I just set these up. All right. Use the IntelliCAD version because it's a little faster and it's more stable for one thing. So I'm going to go ahead and start Carlson. Go ahead and do that on your end if you haven't already. And you may or may not get this update wizard, in which case it tells me there's no update available. I'll hit exit and it should go on and continue to load and come up with my create create or open a file dialog. And so this comes up, it's very similar to the Autodesk start page. You can see up here at the top of my screen here on the, on the, as soon as it gets through thinking about that. But up here in the upper left, you can see that tab that says start page, and there where I can do a new drawing, open files, etc. And so once we've done that, I'm just going to do what did I just do? Oh, do what I did. While that was loading, I sent my mouse up in this corner, in the upper right-hand corner, and clicked it right there, and it closed it, and I didn't realize I had clicked it while it was on there. That's why it left us. All right. So I'm just going to go to this new drawing just to have something open for us to be working in. So it's going to, as it's loading the first time, going to take a bit of time here for us. Sorry about that. Plus, I get some lag on file open dialogues when I'm running Zoom that I've noticed the last several classes that I've taught. So we'll hope that we don't get too much of that. All right. So here's part of my drawing openings, whether I want to use a template, whether I want to start with a DWG or a microstation file, DGN. I'll just say, take the default there, and I'll just take the default Carlson template. And we're going to pop into the drawing. And at this point, I'm going to then look at mine is set up to continue with this drawing startup wizard, the startup drawing wizard. Now, one thing I want to ask everybody is I've got my resolution set a little fine. Can everybody see the things on the screen without me having to zoom into?
I'm good.
You
Yeah.
good with that?
Fine. Yep.
I like teaching young people. So anyway, your day will come. All right. So right now I can just exit this if I want to go through it, but I'll step you through one of the reasons that we like to have this wizard going is we're going to set a few things, like I'm going to be in English units, and that usually I'll never change because I'm always doing that. And that's 1 inch equals however many feet. And I can then put in a horizontal scale. Now, what happens here? If I've got a horizontal scale, that means 1 inch equals 50 feet. Well, that doesn't mean if I'm drawing a line that's 200 feet long, that it's going to create a line in the CAD system that's 4 units long, 4 inches long. All that means is if I plot this resulting file that I've created with an intended scale of 1 inch equals 50 feet, then that 200-foot long line that I've created will measure 4 inches on the paper. But inside the CAD system, it's still 200 units long. It's always going to be, one-to-one real world sizes that we're talking about in the CAD system. So that's not what's going on. What this is used for, though, is to calculate for you things like right here, this symbol plot size and the text plot size. In most dialog boxes, when I'm getting ready to do something like, say, put the bearing and distance on a property line, it's going to ask me how tall do I want, how big do I make my text? How big do I make my circles that represent the property corners? That's a symbol. The text is talking about the text. And so what I'm going to do in those dialog boxes is I'm going to say, well, I want it 1/10 of an inch tall. There's my 0.1. Or I want my text to be slightly smaller than 1/10 of an inch. It says 0.08. Or in the case of most of the public agencies around Pittsburgh that we have to deal with, the absolute minimum text size they'll accept is 1/8 of an inch. So that's 0.125. And the reason for that is because they usually, you know, file archive things at half size paper and they want to still be able to read it. So all understood, but this way I don't have to stop and do the calculation. Let me see. I'm going to be in 1 inch equals 50 feet. So 1/10 of an inch on the paper is 1/10 of 50, which is 5 feet. So I don't have to give this number over here. Okay. I don't have to stop and calculate what those numbers are, because let's say I'm plotting this at a scale of 1 inch equals 30 feet. Well, then you can see as soon as I type 30, these numbers here, the 3 and the 2.4, they're going to change. This number here, the 1/10 and the 800ths, are not going to change necessarily. And that's the part that I'm going to supply because that's the way I'm thinking as a human. But this is the number that the CAD system needs when it's getting ready to do its thing. That's what Carlson does. It asks us the human question, takes our answer, converts it for us behind the scenes. CAD creates it, spits it back, and we've got something that when plotted would measure what we've told it. Okay, so that's part of that setting that thing up. So I'm going to put this back at just at a 50 feet, and you see those things changed as well. It's changed back for us. Here's where you could also, and we won't do anything now, but this is where you could set up a predefined projection system, such as your state plane, excuse me. And right now you notice it comes up with one that I've already chosen, because when I choose this define projection, I've got a number of them here that I've used where it says add from, add predefined, add from this, add from file, add blah, blah, blah. These are all ones that I have added because they're things that I have done work in. And there's my Pennsylvania South, but that's the 86 adjustment, whereas up here I'm using the 2011 vertical adjustment. So this is USA NAT 83, and so you can choose all those, add from file, and when you do that you can pick up a specific file that might have it, or you can add a predefined where you would choose different regions in the world and go down and find the actual state plane coordinate. Now, why that's important to us is, and we don't even have to use it. In fact, I'm going to turn this back to none. But the reason that's important is so that if we are taking survey data that was collected and processed and produced to be on state plane coordinate or some type of system, then everything's going to line up. And we can also attach things like aerial photography or aerial imagery that came from, state agencies or what have you, as long as we know what those projections are. Even if they don't match, Carlson will reproject the data because it knows what your file is. It knows what that source file is that you're trying to insert or attach into this drawing, and it will recompute it. It will reproject the data and position it for you so that everything lines up. Okay, so that's sort of what that's doing for us. Now, here is, see down here, you can give it a project name and a number and a location, just sort of this sets some things up on a, for when you run reports, for instance. Now, a lot of people, because they don't like to step through the hoops on this wizard each time, they'll just check this little box right here to skip this wizard next time. That's okay. You can do that because every one of the things that you do with this wizard, you can do as an individual command. The wizard's just putting them all together. These are the typical things you do when you get things started. Okay. So if you happen to not see this wizard right now, and that has been turned on, I'll show you where you can turn that back on if you'd like to take a look at using the wizard. That's a setting that we're going to see where it is so we know how to get back to it. All right. Now, here's the reason that I like using the wizard primarily. Because watch what, so I've got all my settings done. I'm ready to go. I'm going to hit next. Now watch what happens. Ah, you're missing a drawing name. Aha. So that's what's going to keep me from just creating a bunch of drawings willy-nilly in whatever folder I'm starting up in, which is usually in this folder called Carlson Projects, but if I keep all my defaults. So now I'm going to come up here and I'm going to put in a new drawing name. I can put a new drawing name, but right now it's going to go into this Carlson Projects. Well, I'm going to go here and hit the set button, and I'm going to put it in a different location. So I'm looking at this Carlson file interface, which is similar to a Windows file interface. And if I want to go to the full Windows interface, I can just from here hit the browse button, and there's your familiar Windows interface. And you can use that. You've got all the different things like here's your file of type. In this case, it's only a DWG, et cetera, et cetera. So you can do those, but there are certain things that this gives you, like you'll get graphic previews of alignments and profiles. You'll get little boundaries drawn for surfaces. So little things that you can use to help identify the right files. Plus you get in this upper window, files in the current working folder, but down below in window, you get recent files that you've had open or access to, regardless of where they are. So instead of, let's say maybe I was working on a centerline file that was in a location that was, up 2 levels from where I am now and then down another pathway chain. And instead of sitting here and having to go up, down, 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 and navigate my way to it, it's going to show up down here and I can just go straight and open it. Okay. So that's one way you can do it. Now, and so that's one of the one of the sort of benefits that I like about this as well. So now the couple things to note about this dialog. It's always going to be asking you in this top stripe what it's looking for. This says drawing to create, and then it's going to put in parentheses the list of available extensions for the file type. So if I were making a surface or if I said open a surface file to view it, it would say choose surface file dash parentheses TIN comma FLT comma GRD. So that's a tin file, a fault file, and a grid file that could be available for me to open. So you'll see that as a list of options. You got your typical navigation functions over here, like go up a level, go down a level, and whereas you don't see the tree like you do in the Windows dialog over here where you can open things up and, find your way about. You do have, it tells you where you're sitting. You can pull this down and it pulls, when you pull this down, it brings you a list of recent locations, okay? But I've also have a list in this window of my subfolders inside of that particular folder. So I know I'm in Carlson Projects, and here's my folder that I want to be working in, my 2025-0313. So if I double click that, I've also got another folder inside that location called Data Sets for my civil class. So if I double click that, now you see all those different folders in my data sets, but I'm going to go up one level. I'm going to be in Carlson Projects 2025-0313 civil class. And I'm just going to put this one as my first class example. Clever, 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 I know. All right, so there's the first benefit of using the drawing wizard, is that it made me focus on where that's going to go. I'm not working around a bunch of stuff in an unnamed, unsaved file. It's ready to go. And now I'm going to hit next. And it's going to go through a couple of things. And then it's going to ask me to set up and declare a coordinate file. Now, this is where I sort of have a bit of a bugaboo with the Carlson programming staff, is that the wizard always wants you to declare a CRD file or a coordinate file to go with your drawing, but you don't have to have a coordinate file associated with your drawing. It's not necessary to use coordinates. However, surveyors are very, very used to using coordinates because that's their stock and trade. They've observed points, and they use those points to help create things in the drawing, and that's perfectly fine. So, and Carlson started life as a surveying only type program and not also engineering. So back in the 1980s, they were, you know, dealing mostly with these coordinate points, these COGO points, as they call them, coordinate geometry points. So this is just a way of establishing that. Now I'm going to go ahead and step through this, but I may not use any coordinate points, any Carlson coordinates I may not use in this file at all, ever, but it's always going to have that coordinate file sitting there awaiting any kind of points that I may create, which once I'm in the file, I can open up other coordinate files and, mix and match and bring things in from files and put them out into other files, etc. So by default, it's going to come in and say it wants a coordinate file. You can see here on the second line down, and it's going to suggest to go in the same location. There's my Carlson Projects 2025-0313 civil class, first class example.crd. So you see it's going to match the file name, doesn't have to, but it's going to match the file name .crd for coordinate. Okay, and it's also going to tell me the data path is up here at the top, and you can choose the set buttons to change any of those that you want. And then it's going to ask you, okay, once you've established that file, do you want to import any points into it, either from a data collector, from a text file, from, and this, again, the programmer should have said, instead of current file, they should say existing coordinate file, because the current file is the one I'm creating right now. But anyway, or none. And all that's doing is going to be the same as if you'd gone up to the points command and says import points, and then you go through a bunch of dialogue. So the wizard would switch you over to those commands and then bring it back. We're not going to bring any import here. I do want to point out this though, if you are using coordinates, and perfectly fine if you are, but when you start up a drawing, and if you come down here where it says coordinate file and you hit this set button, it's thinking that you're looking for an existing file. Okay, so if I navigate my way around, I'm going to say that's going to be my set button. But if, however, and you see up at the top, select coordinate file, CRD, CRDB, CGC. All right, so if I happen to be on this new tab, however, if I say new and if I choose this file and it's on the new tab, it's going to overwrite that existing file. So just be careful when you look at that to always make sure to pay attention to these tabs at the top, whether it's new or existing, okay? So anyway, with all that being said, I'm just going ahead and letting it create this in my working folder, which is a level above my datasets folder. I'm going to say no import. I'm going to say next, and it's just going to wrap up and finish. Now, you may get something like this that you see down here on my command line. It says warning due to a known limitation, and this is with the an AutoCAD format. I'm not sure if this happens in AutoCAD or if it's only in TeleCAD, but it says warning due to a known limitation. I'm unable to set the annotation scale for a drawing saved in older DWG format. Now, this older DWG format that it's talking about is, remember I started with that default drawing template called Carlson.dwg? Well, that's been hanging around on my computer since, I don't know, 15, 20 years. And it never has been updated and resaved in a new version of AutoCAD. So it's used it, it's able to open it and read it, but it's unable to synchronize this annotation scaling, which is what you see over here in this bottom status bar here, this little 1-to-1 icon you see, whereas it's asking for my annotation scaling, and that has to do with the size of text if I'm plotting things at different annotation scale. And so if I go up here to my settings and go to my drawing setup, and if I were to change this to say a 30 scale, and say okay, now you may have noticed, and let's pull this up here and let you see my command line. So I said, here's what I had just shown you before. I changed my scale to be 30 scale, and it comes back again and says the same thing. Because, and then you see this point symbol size is 3 and 2.4 because I changed to 30. So there's my 1/10 of an inch. There's my 800ths of an inch at 30 scale. So it's computed those, did all that in the background and sort of left alone. But the reason that it finished, or that it let me dock this. What's going on here? There we go. All right, so the reason that it said it again is that just a sketch, is that it's trying to do something. It's trying to set the annotation scaling based on what I've told it my drawing scale is. And if I go to my settings menu and choose Carlson configure, third one down, feel free to follow so you can look and see what we're looking at. And under the general settings button, upper left, over here in the left-hand side, I've got a switch set that says set, it's the bottom one on the left-hand column, set annotative, or the annotative scaling, to match the drawing scale. So that's what it's trying to do, but it can't do it for whatever limitation is in place because it is a it's a drawing file that's based on a template that's from an older version. All right, so I'm going to cancel and exit that. So if I switch that to 1 inch to 30, I have to come down here in my see what it's trying to do is try to make those 1 inch equals 50 feet. So now I'd have to switch it So it's not able to automatically switch, but it will allow me to switch it. It did create these based on the drawing scale, but it didn't allow me to automatically switch it, which it would do if it were a newer format. Now I see 1 inch equals 30, that's 1 paper unit equals 30 drawing units, so that's 1 inch equals 30. Now that's also the same thing if I look at 1 colon, well, let's look at 1 colon 40, modify that, and that's also 1 paper unit equals 40 drawing units. Now, you don't really have to remember any of this stuff. I'm just showing you a couple of things that is going on behind the scenes. A lot of software like this would, they treat this a little differently. Like 1 inch equals 30 feet. Now, when it does it here, it says, 1 unit on the on the paper when you plot it. And in this case, it's going to be inches, represents how many units in the drawing. Well, in this case, it's going to be, we're working in feet. So 1 inch equals 30 feet. So that's fine. And it says 1 inch equals 30 feet. But you see this 1 to 30. Now, AutoCAD, and therefore IntelliCAD, because it has to mimic AutoCAD, it says 1 colon 30. That means 1 paper to 30 model units. But what most drafters will tell you, or mathematicians that are used to using true scaling, 1 to 30 means just that. It's a comparison of similar units. So a 1 inch equals 30 feet should be a 1 to 360 ratio, because there's 1 inch to 360 inches because there's 360 inches and 30 feet, right? 12 inches to a foot times, so 12 times 30 is 360. So that ratio should really be 1 to 360, not 1 to 30. So just be aware of the way it treats it here, which is just unfortunate that it's using the colon. It should, maybe if it had a double-headed arrow, that would make more sense, because the colons are actually used in mathematical expressions. So anyway, all that being said, that's for another day, another topic. That's your annotation scaling. But if you ever see that message, and if you're expecting it to automatically change the annotation scaling for you and it doesn't, then that's why, is because it's based on an older version. Okay. So with that, we are in the file. We're going to come back. We're going to take our little break, and we're going to come back and um, pick up here and talk about some settings, get them set correctly. And then we're going to jump into the wonderful world of three-dimensional modeling. So far, any questions? I know it's the boring part of it, but anybody got any issues? Everybody good?
Good.
Yep, good.
No. All right, so let's put a bookmark in it, and let's come back at about let's say quarter till, and take care of your phone calls, take a bathroom break, get more coffee, whatever you need to do. I'll see everybody back. I will pause our recording, and I will record. So trust everybody had a chance to get a couple of housekeeping things taken care of. Everybody good? Everybody back?
I'm back.
Back.
All right, Josh.
Yep, I'm good.
All righty. All right, so let's jump into some settings and see a couple of things that we want to uh, make sure we either have or do not have, depending on what our, what our preferences and goals might be. So what I want you to do first is, let's go to the draw menu, and let's simply draw, let me see, let's draw a rectangle. And this is just a standard AutoCAD rectangle tool, rectangle command. So it asked me to select the first corner, so I'm going to click here and drag out here. But what I want to do is I want to give it some dimensions just so you can see. So I'm going to type D for dimensions. See my option there on the command line. And I want its length to be 235.15 feet, let's say. And let's make its width 137.5. Okay. And then I'm going to hit enter to finish. Except, oh, I'm not. I'm going to repeat the command. I'll pick dimensions. There's my length. There's my width. And now I need to simply click the mouse. I forgot to click it. So now I've got my rectangle of those dimensions. It's either way big or it's way tiny. I don't know. You can zoom in and out with the wheel, double click the wheel to do a zoom extents, and then back out away from it a little bit like so. Okay. So here we've got a nice little rectangle. Now let's go to the annotate menu over toward the end on the right. And let's choose auto annotate. And you can have this, all kinds of different options in here, and yours may or may not match mine. That's fine. Just whatever it's going to be, just take the defaults, say okay, and select the rectangle you just drew. And there you can see that it has labeled or annotated our figure. If you select a piece of that annotation, in this case, that's the bearing over here on the left-hand side, and I look in my properties, and if you don't have your properties up, you can right-click and choose properties, and I usually just keep it docked over here on the side. So I see that it is a piece of MText, of multi-line text. It is a standard AutoCAD entity. Same thing if I select the actual figure, I see that it is simply a polyline, okay? So Carlson has done something. It has read this, calculated out what it is, and placed the labels in here. And they're just text, and I can move them, wherever I want to reposition things. Okay, so any of that's fine, and I could put that back down. But now watch what happens here. And yours may or may not do the same. I'm going to select the rectangle, and I'm going to grab the grip on the corner, and I'm going to pull that corner in a little bit. So what happened is in my case, it recomputed and did that. So had I labeled this figure by trying to, calculate the distance from point to point and the angle that it was, and I typed these in and put text on, it would just be dumb text. But these have what are called reactors. And you can see in our drawing utilities, you have the ability, and I've really never had to do this, but you can remove that extended entity data. You can remove these reactors, and that's what those are reactors if you want to do that. But we don't necessarily want to do that. Now, what caused that to happen is a switch here. Let's go to settings and look at Carlson configure, general settings. And it's over here on the right-hand side where it says object linking. And I said link labels with line work. Now this works not only for like, maybe this was a piece of property, but it can also work with the stationing along a center line. It can work with, profile labels, elevations and stations and all that kind of stuff. Anything that is created with a Carlson command to annotate those figures is going to move and recompute and go back in just as if you had rerun the command. Now, let's turn that switch off. Let's unlink labels with line work and choose OK. And then choose exit. All right, now let's draw another rectangle. And I'm just going to draw a standard old rectangle. And I'll put this one up here. It'll be smaller. And let's go back to annotate and auto annotate. And again, take the defaults and choose that figure. And there's the annotation on that one. Now I'm going to take that corner and drag it out and see what happened. The annotation did not follow. However, to fix that, I could go to annotate, auto annotate. And right now, based on my original default settings, which I can find out here under general settings, I'll click that button. And I see somewhere, yeah, right here in the about midline down, it says previous labels. You can either keep them, erase them, or prompt before erasing. So I'm going to have it automatically erase those. So all I have to do is simply recompute or rerun that command, and it erases the old ones, redoes the new ones. Okay. So that's if the linking is turned off. Now, what happens if I do that again? This, or let's go back and turn it back. Or no, we leave it off. We saw that it doesn't recompute. Now, go back to the original one that you did before and do the same thing with it. Let's change it. Notice it does still react, even though our switch is off. And what that is, and what you need to learn about that linking, is that whatever it is set to at the time, so go back to Carlson configure general settings, and I'll turn it back on. And now, if I come back here and do this one, notice it still doesn't react because it's whatever the switch was set to at the time you created the figure is going to be governing the behavior of that object. Okay. So why you might want that on and off would be mostly for things like surveying, annotation for boundaries and such. Let me go back now and just auto annotate this thing again. So what would happen is a lot of times in surveying, we will label the meets and bounds based on the deed descriptions. Okay, and so you might get a little bit of, maybe you found some actual corners, and so your line work might, tweak up these numbers a little bit if you go straight to corner to corner to corner to corner, but you might want those to be based on whatever the deed might say. So you might have the deed figure drawn, annotate it, and then you go in here and you start tweaking around where the lines are actually going to a different point that you might have found out in the field. And yet you want the annotation to remain with what you computed the last time. So in that case, you don't want to be, tweaking these lines around a little bit and having it, change. Like maybe you've just done a little bit. So you want to keep, now in that case, I turned it back on. Let's see now, all right, now I just made a liar out of me because now it is reacting. Well, the way it used to work and the way it's supposed to work is that it remains based on whatever the setting was at the time that you created the file. So that still should have not updated, but apparently it did in one direction, but doesn't in the other. All right, so that's a case of there's not one right answer as to what you do, but I find that most of my settings, that's one of the linkings that I like to keep on. Just in general. So if you have a particular need not to have something, certainly do that. Now let's take a look at some of these settings and what we need to have them done. We're not going to go into all the explanations, but I want to run through these so you can see where they are and what they need to be done. And by the way, notice on the bottom of this dialog box, there's a load and save. And you're going to see that on the bottom of almost all dialog boxes. So you fill out, in fact, let's exit that and go back to the auto annotate. I told you just to accept the defaults. Well, that's where you can come in here and you set all of these different things. And let's say you set them up and you get it the way you like it one time, but then you've got a client that has a different need or something, different size text or different ways that you're going to do something. Well, you can also come down here and load and save. If you save this, you save it out to a file that you can then load back later so you don't have to go back and redo all these numbers again. It just brings them back from that save file. So keep that part in mind as you work through your software. You're going to get a lot of those, excuse me, you're going to get a lot of those that you can save and exit. And when you save at this level, at this top configuration level, there's like 65,000 different settings that it saves. In fact, if I do a save as, and I'm just going to put this here, I'm just going to call it, I'll call it junk. But you see, usually I have like a before class global settings, or I might have IDECR. That's a a contractor that I did some training for out in Idaho. But let's just say maybe I'll call it junk defaults, or I'll call it junk defaults -2. So it's now saved that, or in the process of, and say, ooh, it's up to 97,505 settings. Okay, so more than 65. It used to be from older versions. All right, so you see that can save you a lot of time, you might imagine. All right, so let's take a look at these. There are settings down below here that you probably don't need to worry about ever setting. The localization settings, and this has nothing to do with the surveying term localization, like when you're localizing a set of coordinates from like GPS control. This lets you localize into different, different areas in the world. Like here, I'm going to be in English, and then you got different categories of different things like area defaults, drawing setups, and you basically are going to be putting in default values of what you want based on metric or English, the particular configuration default that you want to set these up. So if you want annotation default, let's just go to drawing setup, for instance. So you might want, here's my configuration, default value of 20, my metrics 1,000. There's my English default. That was when I first started the drawing. Remember, it proposed that 50-foot thing. So all of these things are preset from somewhere else. You don't have to go through these and set them. That's what I'm saying. You don't need to really worry about that localization stuff. That just lets you switch it to a different location that you might be working in. Okay. Takeoff and SiteNet. This has to do with the way surfaces are modeled and whether or not you're going to use these automatic colors based on whether they have elevations or not, and whether it's existing design or other. If you're using the takeoff or the SiteNet commands, and in SiteNet, you don't get advantage of the colors, but in takeoff, you would. And then down here are where you can put in these little uh, affixes or suffixes in this case. An affix would be either the prefix or the suffix. These are suffixes that go on the file name of these specific surfaces that this process creates. And that's a different thing. We're not going to be doing much of that, but that's a sort of a different way of computing surface. And we'll take a look at that briefly, but these are just some default settings that you can set. And you're not going to have much need to change that if you don't use that process at all. All right, so we'll cancel that. And then you've got mining, a lot of things about how it creates gridding. Now, Josh, you might have some need for some of these. So I'll go through these real quickly here. These in the upper part are going to tell it that, all right, I'm going to, let's say I've got a bunch of sample points that I'm going to be modeling. For instance, if you've got drill hole data, you're going to go out and look for a maximum number to use to help you create the surface information at the point that you are at any given moment. So I'm sitting on a particular drill hole, but I need to look around at my neighbors so I can figure out whether I've got, strata run out and pinch off and all that kind of stuff. So I'm going to look for 20 other samples around me, and I'll stop after 20. And you can set, all right, I need a minimum of so many per quadrant. That's northeast, southeast, southwest, northwest of where I'm standing. And if you want to make sure that let's say if you don't have any in that particular direction, 0 would still allow it to model. If you said, I need at least 5, it's going to come back and give you an error that says you don't have enough data. And then you can say, well, the maximum amount you want in any given one quadrant. So you can set those limitations up, and you can give it a radius of how far out to search. In this case, it's going 10,000 feet or roughly 2 miles away. And whether you're using conformance, so it's going to try to mirror the ground surface when and where it can, fill in missing strata, et cetera, et cetera. And let's see, anything else that you might want to look. You can establish the particular material that you're looking for and whether or not it has names in the drill hole data, like that's the key strata. This is your overburden. These are your partings, and this is the bottom of the strata itself. All right, so those are some settings that come into play if you're using the mining modules. Now, if you're not using the mining modules, Josh, and you may not be, you don't need to worry too terribly much about this. And all of these, by the way, can be set at the time you model the data. You don't have to preset them here. This just sets the defaults, okay? Now, mine notes that if you're dealing with underground mining, you get a lot of these things, SPAD notes and such, and thicknesses and offsets, any kind of underground mining as opposed to surface mining. So down here's your SPAD symbol size and the offsets, etc. So we don't need much with that. Hydrology, again, is whether your pipes are measured center to center or the actual pipe length, center to center. And this is showing you that center to center, this is 100 feet, and the actual pipe length is 100.02. So in center to center, it would read that as 100 linear feet at 2%, whereas in if you're using the actual pipe length, it's taking out that 2 feet and that 2 feet and applying the slopes. If you got the 2 feet, 100 feet of linear feet at a slope. So it's 100 minus 2, so 96 at that 2.08% slope in that particular case. Although that's not, what do we got? We got 1 foot, so that, yeah, so those slopes aren't actually correct. That should be a 1% slope in both cases. But anyway, you get the idea. Note 300 feet at 870 equals 301 feet slope. That's just an example. I don't think their numbers are matching up very well. But anyway, that's just a couple things that you would do if you're using the hydrology module and you're using it to automatically label your pipes and such. So nothing much there. Section and profile. This is potentially available if you're doing any kind of like roadway design where you're calculating site distances and such. You're given an eye height, an object height, and this vertical curve drawing resolution is it's a factor. It's not a number of segments or whatever, but it's basically a factor, and you can see in the help system, for instance. Let's see, section profile. So there's your site distance, vertical curve drawing resolution. This applies to draw profile for the segment length for drawing vertical curve. Now, it doesn't tell you that it is a factor, but it's actually not, it's not going to segment those vertical curves, which are parabolic. It's not going to segment them into 10-foot segments. It's just a number that's a factor. So if you're finding out that when it plots it, it looks too segmented, you can increase that number to make it put in a greater number of segments, and so therefore the segments are smaller and they appear to be parabolic as you look at it on the screen. Okay. And then the station type and that kind of stuff, and whether you're using the crest site distance formula for SAG, yes or no. But again, just setting defaults, we can always change those at the time we're doing the work itself. Now, surface settings. This is where we're also going to be, and this might be, Josh, where you would set this in as opposed to under the mining settings. And there again, you see that 10,000 foot search radius, maximum samples, maximum per quadrant, minimum per quadrant. And this is the default when you're doing a grid. You want to use the number of cells in an X and Y direction, or you want to use the dimensions of a cell, and you would and when you choose that, when you run the command, it's going to ask you for those dimensions. Like you might want to say every 5 feet or every 200 feet. It depends on how big your data is. And it's going to recheck the maximum number of times you want to check for any crossing contours, et cetera, et cetera. Save the grid using binary. Simplify difference tends to reduce the size. There's no real need to do that. Because the computers can now handle these larger data sets. You might as well keep all the data. But here's something that everybody might want to do, and that is to track your TIN history and include the detailed source data and track any changes to that data. And what that's going to do is once you build a surface, there are a number of ways to modify that surface. My preferred method and what I teach is to, if there's a need to change that surface because let's say you need to, switch the direction a break line or switch a triangle leg or switch the direction that the triangle actually forms because sometimes it's arbitrary, then you can make that edit by saying swap triangle edges. And if you do that and you don't have this TIN history stuff being tracked, then when you go in and do something else to rebuild that surface or modify the surface, it's going to lose track of that. You'd have to go back and do it all over again. So if you do have it, you have that history that you can go back and reapply those edits that you made. So if you're, sort of predisposed to editing your tins after they're done by looking at the surface and maybe removing points or swapping edges, having this history on will allow that to persist as you make any other changes. Now, again, my particular preference and what I like to teach is when I look at a surface and I see I've got a point there that shouldn't be there, I go back and recreate the surface and exclude that point. Or if I needed to add a break line somewhere to control the direction the triangle edges are going to form, I'll draw that break line and then include that in the data that builds the surface. So now I know it's going to always work because I've added to the data. I haven't made the edit to the triangles. Okay. So, but if you do make triangle edits, then you would want to make sure those are on. Okay. And then, see, survey settings. just a couple of things here, is if you are using the survey module, there's a couple of things on it. The very first thing is up here at the top. Now, it used to be that this default said compact. I don't know what it says now out of the box. If it says compact, you would see that menu on the survey settings, and that is from the old C&G, the old Cowherd and Goodman survey software, because Carlson bought that entire company, and a lot of their customers were very familiar with that software. And to help them as they made their transition, they allowed that entire software system to live inside of Carlson, and they put this in as a little menu. If you don't have any need to run that C&G survey software, set that to none, and it just takes it out of the menu space so you don't see it and it didn't get in your way. Now, the initial traverse and side shot angle modes, I like to have it prompt me, but if you're always using angle right or always using azimuth, you can set that accordingly. Show the occupying backside points on the status bar. That doesn't work real well in IntelliCAD, and it's not all that necessary. It's just a little reminder down here on the bottom. It will show you when you're doing COGO commands what your occupied point, your backside point are. Automatic raw file and line on, and again, all of these things you can set as you go through the commands. But that's if I'm doing COGO commands or traversing commands, for instance, if I say automatic raw file on, it starts to record those commands so I can then go back and edit that raw file. Let's say I typed in a distance wrong. Well, instead of having to go back and redo all the work, it will give me that file that I can keep going and then just go back and make that one change where I typed in a bad number and recompute it. And it will, it's sort of like the difference in using an adding machine versus a spreadsheet. If you're using a spreadsheet, you've got all the numbers you've added up. You can go back and fix something in a number instead of having to go back and re-add all the numbers with an adding machine. Okay. This automatic point object snap on, that's for Carlson points, and that is also settable on the settings menu, and that's just a way to make sure it always snaps to the actual point location instead of you having to zoom in and snap to the origin of the block or the node of the CAD point that is also part of a Carlson point. You don't have to worry about that. You can just point to any part of it, any part of the label, anything, and it always goes to the center of the point. It's sort of an additional object snap that AutoCAD doesn't have. AutoCAD has a node snap that snaps to the CAD point, but this allows you to even just go out and pick on a part of the label and it jumps to it. So it's pretty handy if you're using points. And then you can have it automatically look at any points in the drawing, compare them with the coordinate file that you have associated with it. When you start up the file, it will tell you if they have a mismatch, and you can fix that if you need to. And then this automatically check any Carlson community. That's it's an online thing that you can join for any missing symbols. It will find out if you've got symbols that have been named as blocks that are named in your drawing, but you don't have them, then it can download those for you. Enable your transparent point commands. That's like snapping to in the middle of another command, like you're drawing lines and you need to go to a point that is to be computed, but you haven't computed the point yet. But the point might be at a certain distance away from one point, intersecting with another distance from another point. And so that will allow you to do those in the middle of those other commands. Land desktop field book codes, if you're doing field to finish and you need to resolve some of those, you can set up a code table in here to have it read those existing codes. But again, not much here to really worry about, except I would turn this C&G menu off if it's not already set to none, unless you're using it. Okay. Now we're going to get into the 4 areas that make sense for us. And that is under the startup settings. This is going to allow you to point to a particular template that you want to use as your default. Again, you can choose that when you're starting the new drawing, but by default, it's going to offer that Carlson DWT, which is my template file, my startup file. What is my startup folder location? And this profile name, I wouldn't really change that. That's set on installation, but you might, if you've done any kind of configuration changes and saved to a different profile, you could set those up. A command switch is either like a no logo, so it doesn't bring up the IntelliCAD startup logos, but you'll see the Carlson stuff unless you turn off this splash screen. All right, so pretty straightforward there. And then your project data folders. This is something that we'll talk about. You can see it here in the book under organizing your work. It talks about this directory structure, and there's several models. There's one by default is using the drawing folder configuration, or what we call follow the drawing. Okay, and the other options are, you can see them right here. You've got either a project folder, a drawing folder, or a fixed folder, which just goes to some default folder location. If we choose drawing folder, and that's the way it is by default, all of the data files that we save or load are going to, by default, start out looking in the same folder that your drawing lives in. If you give it a fixed folder, it's going to go to that folder. If you say a project folder, then it's going to go and look in a list of folders that you may have created and told it that that's where I want to store these particular types of files. Okay. It's not, I wouldn't say it's not often used. We do often use it. In particularly in larger organizations, if you got multiple offices, and that way everybody knows where everything is, and they can sort of, be assured that that's where things are going to live. And again, all we're setting are folder locations that come up as defaults. So if we look at, for instance, the project folder, and we look at this subfolder setup, what this is this is a little something that I put together. You can do your same thing, add and remove. I've got a folder called wherever my project is, whatever that is wherever I create my first drawing and assign it a folder or assign it a project name. It creates a project or creates a folder of that project name. And then within that folder, it makes a folder. It makes these individual folders. There's one called data, one called drawing files, one called other, and one called program settings. And within data, I've got alignments and profiles go in that folder, deed information, mining stuff, points, and then surfaces. They're all going to go in those individual folders. And then other, I've got things like contact information, deliverables, point cloud, PDFs. You might have, a folder for site photographs, things like that. All right, so this is basically just building that list of surfaces. And then that was my setup. And I've got this data type subfolders where I can assign all of these different types of files, like a CRD file, for instance, is a coordinate file. Right there it is. So it's going to go in my project, whatever that name is, data points. And when I pull this down, that gives me a list of all of those folders that I showed you in that previous step. Now, if you need to add another folder, you can go back out here to these edit subfolders, and that takes you back to this area to create those. Notice you don't have to set all of these to a different location. They all start out going in either project or settings, but you can assign, different ones to different things. Notice there's 271 individual file types there, at least showing here. Your number may be slightly different, not sure. But these are all the file types that you're going to see. Now, here's something that's a nice little trick. Right now, I keep mine as my drawing folder, so everything just goes to each individual drawing location. But let's say I see a file in there that I don't know what it means. Let's say I see an extension on a file that says .his. Well, I may not know what that is. If I pop into this little thing from my project data folders and temporarily switch it to the project folder and I go to my data type subfolders, notice I've got all these and I can sort these by clicking on this. So if I sort it alphabetically, which I already am, and I'm going to scroll down here and I'm going to find an HIS, except of course that's not one. Let's say it was an HST folder or an HST file rather that I saw. And I look over here and I see, oh, that's a horizontal speed table. Or what is a file that has a PRO extension on it? I'll scroll down here, I'll see a PRO. Oh, that's a profile. That's what that thing. So this is a nice little way. It shows you every individual potential file and those extension. Here's a called a vegetation layer settings file. Okay, so these are all of those different down here as ZON files, your earthwork zone definitions. Okay. So that's a nice way of saying, and I'll just come down here and cancel, and I'll set this back or just cancel that from whatever it was. So that's a nice way of saying or finding out. You just go here and hit this data type, and you can find out what that is. So it's a nice little trick. All right, so then finally now, or not finally, but next, the drawing setup button, the upper right button out of the main one. This is going to set up what we want to use as our current settings, but you would give it a, whatever you normally start out with. And in this case, like if we're starting a new file without a template, like mine comes up, mine had that 50-foot, but right now this one says the 50-foot came out of the template. But if I use this without a template to start with, it's going to preset that horizontal scale to 20 feet. And again, that's just the desired plotting scale. It has nothing to do with how long you make certain things in the drawing. They're always going to be at true length. But let's say 1 inch to 20 feet horizontally, 1 inch to 4 feet vertically. That would be like profiles and cross sections. So it'll be a 5-time vertical exaggeration, or you can set those to match. The symbol size 0.1. And again, when you see these, they're going to be talking about in terms of plotted inches if you plot at that scale. So those are just my default settings for that. I can set a particular symbol name, different categories, points, trees, inlets and manholes, that kind of thing. And you can add to that library, etc. And we'll talk about that in the fundamentals class. And then vertical angle mode, whether you're going to use a drawing template or use this configuration. So I'm using a drawing template when I start up, and that's where it preset that number for me. For points, if I'm labeling points, I'm putting in Carlson points. What attribute layout do I want? I like them all lined up on the left, and it's opposite the points right here in the middle, but my default is a 1, where point number is centered over the point at the top, elevation is off to the right. The description, which it's hard to see on my screen, but it's that green label there. It gets centered underneath the point. So different ways. You've got some where the elevation's kicked up at an angle. You got some that are in just different orders. You can see a little preview of it there. And whether or not you want to use and prompt for descriptions and elevations and place it on the right elevation, if you don't have that done there, when you put a point, it goes down at elevation 0 in the drawing. But if you're reading the points, it reads the elevation from the point data. But I like to see them right where they're supposed to be. Let's see, a couple things where you use automatic point numbering, and I like to have those on. and then you can use a predefined grid system or just a local coordinate system, which is not using a projection. And right now it's by default coming into my Pennsylvania South, the 2011 vertical adjustment. All right. And finally, and this is the big one, is under the general settings. And this is where a lot of things get set. Now you don't change these often, but this is what governs the behavior. We've already talked about some of that object linking over here, and you can see what those are. Linking line work with center lines, meaning if I draw a polyline and turn that into a center line, then if I edit the center line in the data editor and I hit save, it's going to come back and redraw that center line to reflect those changes. Likewise, if I just grip edit that polyline, it's going to go into the data and change the data to match what you've changed on the screen. Following line work with points is if you created line work based on point numbers, based on Carlson points, then if those points move, the line's going to go with it. Okay, so it sort of sets up that association, that reactor. Okay, and again, whether it's on when it's created or off when it's created is going to govern its behavior. So here's some of the settings that we like to use. Here's the first one at the top, this use the startup wizard. Remember when we start up and I showed you that lower right-hand checkbox that says skip the startup wizard next time? This is where you can turn it back on if you want to use it. Okay. So I would leave these set to, I'm going to uncheck this one right here, the software rendering. Don't turn that on for yours. I have to because I'm running through a Windows emulator on a Macintosh. So I have to use software rendering on that. It does not take advantage of the video card, but you're going to be able to if you're running under native Windows. So I would set these to be what you see here. And if you set this annotator to drawing scale on, all I've done here is in this label, this is what it's going to create for me in the labeling. This one is an inch mark, space, equal mark, or equal sign, and another space as a prefix, and the suffix is a foot mark. So that's why you saw when we looked at those annotated scalings down here on this bottom part of the screen, that 1:30 that previously existed, but when I changed mine to say go to 30 scale, it created a new one called 1 inch equals 30 feet. And that's where it is getting this. Okay, so I could have just used you know, a colon here and nothing here, and it would have done 1:30. All right. Setting the active scales just let you add to this list of scales, and there you see that 1 inch equals 30, 1 inch equals 50. You can then suppress these if you don't want to use them by clicking those, etc. If you uncheck support all, and you can turn these whether they're on or off. I'm just going to make sure they're all on, and you can set those accordingly. All right, so I'm going to leave this up here and let you match these. We won't go into what they all mean. Again, that's typically in the fundamentals class. I don't want to take too much time away from our work. So go ahead and match that, and let me know when you're done, and we'll say okay and get out of settings.
I'm good.
All right. Thank you,
Yep,
Ryan.
good.
Thank you, Ryan.
Yep.
Okay, I'm going to turn my software rendering back on. You don't need to. I'm going to say okay, and then I'm going to say exit. And it's going to tell me, because I visited that drawing setup change, said, you want to apply that to the current and future drawings or only to future drawings? I'm going to say future only. I'll leave this one set to whatever it was. Okay. So that's that. And that's where you can make those changes. again, under settings, you also have this settings explorer where they have all kinds of different categories. You can see there's for CADNet, there's for civil. And so all of these different things that's going to set, these are all of the answers to the dialog boxes. When you do something like, if I want to assign contour elevation to a single elevation group, this lets you set a starting value and all that. You don't usually do much with this, but it does give you a way to jump into some of those dialogues and set all of those different things. So, that's there if you ever need to use it. And again, that was settings, the settings explorer. You've also got a settings file manager where you can see all of these different, code definitions. Under survey, under general, you've got all of these saved dialogues that I've, set up and saved as I've gone through it all. All right, and those are the things that are in whatever settings folder. You can change to a different location, maybe out on the network somewhere. All right, but these are the ones that live in those particular ones. And if I looked at my field code for, say, Leica, and if I just double click that, I can set it current, and then you can do some comparisons, etc. All right, so just let you look at those individual saved settings. Again, something we don't often do. All right. Now, a couple of things that we want to take a look at that are handy, particularly if you get files from outside people. And so I'm going to go ahead and I'm going to close this first example. I'm not going to save any changes. I didn't make anything. So I'm just going to close and come back here. And I'm going to open files. Now this time I'm going to, right now I'm sitting in my civil class. That was the file that I just had. I'm going to go into my data sets that I've downloaded for the class. And I'm going to open up this file at the bottom called sample from T3 Global. I'll hit open. Now, it's going to bring up a file that was produced by a photogrammetry firm, and you're going to see basically everything showing, including these sort of random looking white lines that you see. Those are the break lines themselves. They're on this layer. If I select that and I see it's on a layer V topo BKLN, that's survey is the V designation, so it was existing. It's a topo category and it's a break line. So that's even showing there, but I see I've also got some contours and I've got some spots that you'll see light up here. They're just individual points. Okay, so that's all of the data that was used to create the contours when they compiled this data. And so if you're wanting to sort of get a sense of what's there, notice I selected this, I looked over here and saw what data or what layer is on. If you're using AutoCAD and if you hover over that, I think it pops up a little mini properties and shows you. But if you don't have that, and if you're using IntelliCAD, one of the things that you can use to identify that is on our inquiry menu. And that's called this drawing inspector, on and off. It's just a toggle. So if I turn it on, nothing seemed to happen unless if you're really paying attention, you notice my cursor has now changed. It looks like the AutoCAD cursor plus the Windows arrow. But I also see on the command line, it says, okay, the inspector is now on. I didn't mean to pop that out. I mean, how do I get that back? Let's see. There we go. All right, so it tells me that the inspector is on and right click to activate the pop-up menu. So if I right click, I get this list of things that I might want to see. And you see that they are checked on, the ones that I want to see. Also, make sure this enable tag display is on. So if it's not, just come down to it and left click the mouse that sets it. And you have to go back and choose it each time you turn something on and off. So let's say if the only thing I want to see is what layer things are on. Well, I'm going to turn off my elevation. I'll right click again and turn off the polyline data. I'll right click one more time and set the elevation. Now that's the quickest way to without having to think about it. But one way if you want to not have to keep right clicking is you can choose this options dialog and set it this way. Okay, so that's probably a quicker way of doing that. And there you can set all of those different things you can bring up as a dialog. All right, so now you can see I'm going to display the elevation. Now what this does, the drawing inspector, is I can be doing other kind of things like drawing lines. I can keep using my standard commands, but now if I just happen to hover the mouse, it looks like I'm reading elevation. Yeah, let me turn, let's undo elevation and look for layer name. There we go. And so now if I just hover the mouse, it's going to pop up a little thing that tells me what layers these particular items are on. Okay, so it's another good way of identifying, what certain things might be in the drawing. If you want to get back to, let's say I'm drawing a polyline here. I'm just going to use the standard, draw a 2D polyline. And now if I want to right click to finish it, but if I want to do something else, like if you select something and right click, you notice the drawing inspector doesn't pop up, but it gets this one to, uh, the standard right click menu. So you can do different things with it. If it's not selected and you right click, you get this. If, however, you like to do the right click that's normal when that's turned off, you can choose this and choose, let me see. I guess if I exit the menu, and no, well, it doesn't really pop that up. It used to be, I thought that you would, yeah, if you use the keyboard enter, which is what I have my right mouse set to, is to just repeat the last command. Then if I exit that menu, you see I normally have, and I'm going to come down here, I'm going to say turn off drawing inspector. And that's the same as if I went up here and just chose that command again from the inquiry menu. Now when I right click, I get this menu where I can get recent commands and different things with nothing selected. So if it is on there and if you're through inspecting, and if you want that to pop back up, then you would turn off your drawing inspector. Okay, so now if we look at the dialogues, and I'm going to say layer name not, but let's look at the elevations and let's look at the polyline data. And so now as I hover over these 3D lines, I see right where I'm hovering, you see that elevation is changing as I walk down that line. And it's telling me the distance. So if I select this, I'm hovering here, you see the horizontal distance is 48.317, the slope distance 4832. It gives me the elevation start, elevation end, gives me the slope in percentage and in ratio, gives me the total distance of the entire figure. It gives me the current distance, that's how far I am from the start of the figure, and tells me whether it's open or closed. All right, so let's see if I do one more. I'm going to set one more thing. Let's look at the polyline direction, for instance. So now you see it's going to sit on a particular feature and show you the direction that it's created in. Okay, so that's sometimes something you want to use. And you can reverse the direction of something, because let's say it's a centerline alignment, but you don't want it to start, over at this end. You wanted it to start at this end. Well, you can reverse that polyline with, this edit command, and it's on the polyline utilities reverse polyline. So you can change its order of creation basically, and you can toggle that back and forth on and off. But that gives you a sense of what you can find out about this drawing just by hovering the mouse without looking at it. So I'm going to right click and turn off my drawing inspector. So now it's not popping up in my way. And let's take a look at a couple of other things on that inquiry menu. One of which is this, again, looking at those layers, but I can also do this layer inspector. And it's going to bring this dialog up. Now, AutoCAD has a similar thing in its layer tools called Layer Walk, which does the same thing, except this gives you a couple of additional commands, like you can still zoom in and out. You can choose to erase things off of any given layer, in which case then if it's empty, the purge becomes active and you can control the drawing from within this. But what this is going to do is it puts this little dialog at the bottom, and you can't really resize that, but you can step through it pretty quickly. And what you do with this is you can tell it down here on these buttons how you want to see what's on a given layer. You want to isolate that layer, and if you want to isolate that particular layer that you choose over here, let's say ditch, but it says there's nothing on ditch. Let's find V building outline. It tells me I've got 7. Well, there I've isolated it and I see everything that's on that layer. If I said zoom, it's going to zoom extents to everything that's on that particular layer. Okay, if I uncheck the zoom, it's going to go back out and stay at whatever level you have shown here. You pretty much always want to keep this restore view on exit, so when you come back out, it resets the status of the layers to whether they were frozen or displayed or whatever. But a couple things you can do with this is you can find that one, for instance, and then let's come down here and I'm going to control click and get a couple of other things. Here's my road curb, guardrail, road outline. So all of these different layers I can select, and I can even at this point erase entities. I can rename layers. I can, all those different kinds of things. So it's another way of making sure things are on the right layer and seeing what all is on the layer. And remember that V topo break line, for instance. So I'm going to come down here and say, find that the topo break line. Now I'm just going to single click it without holding control down so it gets rid of those other selections. And there now is all of those things that are on that particular layer. And again, I can point up here in the plan view and use the wheel to zoom in and out and pan back and forth. So I'll exit that. And notice it now comes back into restoring the view. On exit. All right, so that was one way of looking at it. Now, one of the things that I usually do the very first time I get a drawing in is I look at it in 3D. And there's several ways you can do that. If you've got this little navigator turned on, you can sort of click on this corner right here on the top, and it shifts it around to that viewpoint. And so now if where did my layer go? Oh, I've got something down here. Got a straight point down at 0, 0. All right, so there we go, zoom extents. And now if I go to this corner here, you see how it zooms it up that way. I can hit the top view and it comes back. But a quick way of doing that is if you hold the shift key down and press and hold the wheel on the mouse, see what it's going to do? And now as I move that around, it's going to bring that up into that. Now I let the shift key up, and now I can hold the wheel down and press and push, and now of course it's just back to where it was. And pressing the wheel and pushing, it's in pan mode. But if I hold the shift key down, it lets me go into this rotation mode. Now, some ways back, you can either type the word plan, or you can just, if you can find that top button there, you can do that. And sometimes you have to reset the orientation. Let's say if I spun this all around like this and now hit the top view, see how it's, actually it did come back. Sometimes it comes back where it's maybe rotated like that, and you just have to re-navigate your way back to it. But you always want to make sure that you're in plan view when you do, because a lot of commands require it to be in plan view. So, um, you know, that's when you're seeing the icon down here for your UCS, your user coordinate system, that generally that Z icon will go out. If it's even slightly, you'll see that red Z arrow is going to be there. If it's not exactly on it, if it disappears, then you're exactly in plan view. So
Hey, Ken, how do you, I guess, open up that cube function if it's not in the upper right of my screen?
here, let me see. That's a good question. That would be if, now you're in AutoCAD or IntelliCAD? You're in AutoCAD, I think.
Yeah,
Yeah, so that's going to be in your settings. If you right click and choose, right click, and I think it's all the way at the bottom where it says options, or just type the word options, you're going to get these options. And then on the display menu, is it? Uh, Seeing it here under IntelliCAD, but there is a command, and it's your view navigation. Let's see, view, let's see, view control. View control. No, that just brings that up as a dialog. Let's see.
I found it here. So it's in, if I go under options, and I'm not sure Ryan might make note, but it's you go under options, you go to 3D modeling, and then there's display tools in viewport, and then there's a forget
Yeah.
what I just clicked here. Display the view cube, and then I've got, 2D wireframe visual style and all other visual styles marked.
Okay. So if you want to see that, let me pop into this one. Yeah, I'll just pop up another different file here. I'm just loading. Come on. All right, I think it's finally gonna get here. There we go. It pops up and the dialogues populate and then they'll go away here in a minute. All right, so you right click and chose options. And then that's under our 3D modeling is where you want to display the view cube and display the UCS icon. That's this part down here, and viewport controls, etc. That's the little controls menu. That's this menu right here, and it's just a floating little toolbar. But that gives me that different settings that I had there. Again, that view navigation, and that is if you see the view cube settings. Yeah, there's nothing there that tells it to do it on startup other than your options. And there's a command associated with that. In fact, we may have it see something here. Switch back to this one too, IntelliCAD. I think then view. No, I thought it would be under view cube. Navigation, nope. Cube, there we go. Cube, nav cube, other than cube as a command itself means to run the Carlson version. So if you just type cube and choose that, nope, it's still running the Carlson. Yeah, so those are all the Carlson commands. There is a command to use for it, but I'm not finding what that is. Let me hang on a second. I've managed to screw this up. Well, I'm going to need to reestablish that. I just killed everything in Windows. So probably at this point is a good time to, we'll break 5 minutes early for lunch. And I'll get all that stuff reset. It doesn't take long, but in fact, I'll just come back to, let's see, AutoCAD. Cancel that. All right, let's see here. In Windows. No, should be back. There we go.
Maybe just another basic question. I'm not sure with the view cube, and so I've never like rotated in 3D because then if I ever forget, to go back to plan view, my data gets all messed up and wonky, whatever else. So I
Right.
usually just use like the 3D viewer to view all that
Yeah,
stuff, but I
exactly what I was
I
gonna say.
like this. Yeah, I like this view cube a little more with the shift and control, or your scroll, because it seems like it'd be a little quicker just to kind of manipulate and look at surface contours and all that stuff. Is there a way to set your center of orbit around a specific point? Because it seems
Uh,
like it kind of just centers your data.
no, what it does is it finds the center of the data you either have selected, or if you've not selected anything, it goes to the center of the all of the data. And so there's
Hmm.
no way to set that using that view cube. So that makes it a little difficult. That's why I really like the Carlson 3D viewer that you talk about using. In fact,
Yeah,
the reason I do that shift and wheel is just to sort of get a sense of looking at what might be elevated and what's not. Like, again, just I'm holding the shift key and pushing around so I can see, oh, okay, everything else down there is plan view, but this is my elevated data. And then I have to
gotcha.
go back to that. So that's really the only time I use that. And when I do it as, but if I want to say, let me see if I can grab just a few things like that. And then yeah, see now when I do that, it limits it to what I selected. Now notice there's stuff down at 0. So the center of that rotation is right in the middle of
Hmm.
that data. Okay. So
Yeah.
So that's really the only guidance I can give you with that one. Um, but if I do it with, hold on a second, let's just grab everything. And if I do it with my Carlson 3D viewer, which is nice, and we'll talk about this um, when we get into that. And see, I can use this now to, really sort of fine tune my way around. And there's my hydrology and my pipes. Now these pipes are showing up. You didn't see those in the other view because these are defined as Carlson pipes down in their 2D 0 elevation layout, but Carlson knows their pipes, and so it creates these on the fly. There's my inlets and my head wall and all that kind of stuff. So there's some advantages to that as well with this. Plus, if I want to change my drawing, I just go over here to my settings tab and I can choose this, um, set the CAD view to that current view. And so
Hmm.
now when I exit, it puts me in that same view. But if let's go back to plan view. And if I, do that, repeat, here's the nice thing about using this one as well is, of course, you also get a floating window you can put on a different monitor, or you can put, resize it and still see the drawing behind it, like so. But let's say you use that to identify some things. You say, okay, I see now when I hit exit, I haven't left my plan view. I stay right where I was.
Hmm.
So that might be, in fact, that's what I do other than just getting that initial sense is I put that is I use that Carlson viewer. A lot of people shy away from it because they don't know all the controls in it. So we're going to um, learn all of those controls so it can be really second nature for you. And again, right now it's just, I come up here and click that little icon that you see there, the 3D viewer window on that toolbar. And, I'm off to the races working with that. And I can do so much in that viewer. I can turn layers on and off. I can bring other things into the view if I haven't selected them. I can go back out and pick more things. I can view a surface file superimposed over the drawing elements, all kinds of things I can do with it. So, so there's two main viewers. there's that drawing viewer, that's the cube, but there's this surface file viewer, and it's really the same viewer. It's just what it loads up. This is going to ask you for a file. This asks you to select objects. And so even if you're in one, let's say I'm going to select these objects. Then if I wanted to see, say, a surface that's affiliated with that, and I want to see, you know, how these things fit with the surface, then I can go over to my model tab and I can choose this button, add a surface, and I'm going to go back now, and that's my hydro class. There's my existing ground. Let's see, there's my future ground. So now I can see that. And sometimes I usually have to come back and re-enable. I don't know why my surface is setting currents. I think I may have displayed that surface using elevation zones previously. That's why it's all different colors. But, you know, and I can do multiple surfaces as my existing ground. And then I can, you know, turn on and off various surfaces and see. And then there's, you can see my inlets are right there up on top of that surface. And if I, you know, should go up and look up under skirts, I can see, you know, my pipes are right there under the ground. I can make the surface slightly less opaque so I can see through it. You know, there's all kinds of things I can do here that I can't possibly do with that view cube. And so, um, you know, it's one of the things that I really like about this Carlson viewer. And again, I did that not by view surface, but if I had chosen view surface, it asked me for a file, then I can also go over here to the model tab and then choose add entities instead of add surface. And I can go out and select those other lines and figures in the CAD file that I want to see superimposed. All right, so it's a nice little way, but we'll get into that and learn some of that as we go along. All right. So that being said, I say we're going to break 5 minutes early for lunch. We're now going to be 5 minutes late for lunch, although we will get the full hour. So I will see everybody back at 1:05 Eastern. Let me pause that recording. And I had a little quick note from Erica. It was something I really hadn't gone over to show you, but it might be beneficial. And that is, which toolbars do I have up and running and where they get used from? I'm going to show you a couple of techniques we can do there. I'm going to go back into my sample from T3. As it loads back up here. Oh, come on, Windows. Well, must not have clicked it. There we go. All right, so what I've got here in my setup, you see a number of toolbars, some vertical on the left, some vertical on the right, and some horizontal across the top 3 lines. Now, those are just purely preferential. I'll show you where they are and where you can set them, and I'll let you match them up here in a minute. You can also get to them if you go over to the gray space next to the toolbars up here, just some blank space. Right-click the mouse, and then you can, tell it whether you want to look at a particular menus, whether you want to show the toolbar, and these are several toolbars. You've got Carlson toolbars, you've got C&G survey toolbars, you've got IntelliCAD or AutoCAD toolbars, and then you have iCAD or ACAD DGN, which are toolbars that come up if you're working directly in DGN files instead of DWG files. Okay, then you can choose toolbars and pick from a list. You can do all kinds of customizations, which we're not going to look at any of those there at all. But there's another option here. Is you see this right click and I can switch to ribbon, or I can just type ribbon at the command line, and it brings up this ribbon where I've got file, setup, draft, points, grading. So instead of being the menu type that you see up here across, with the commands down here, these are different ribbon panels. And I think that's the way it installs by default. I don't particularly like to use it simply because it just takes up too much room out of my screen. I like to go without it. So what I do is generally is come down here and say switch to, now I can turn the menu bar completely off at this point, and I've got only these panels, okay? And that's perfectly fine if you want to do that, but I'm going to switch to menu bar instead of ribbons because just, I've used the software for so long and I know where those live, and that's just my comfort zone. Now, which particular toolbars do I have up? And if you see, if I hover over the little handle on these toolbars, you see the name of the toolbar that pops up. There's Carlson menus. Here's one that says entity snaps. Up here's one that says layers. And there's actually 2 different layers toolbars. One's from IntelliCAD, one's from Carlson. So here's what I've got up and going. If I go to my settings menu and look at my, let's see, not the manager, but my toolbar setup. Okay, that's the same as if I right click and choose it from that context menu as well. So here's what I've got on and displayed in various places. And notice up here, you've got the different categories you can choose from. So here are my Carlson menus or Carlson toolbars that I have showing. I've got Carlson menus, I've got draw, I've got entity properties, things like, color, line, weight, layer, things that they go on. And that's this business right up here, these pull down fields. I've got grading. I've got inquiry. I've got layers. And I've got polylines. I've got standard and surface. And then finally, my transparent point commands, which are docked over here on the right-hand side, okay? So I'll let you model those if you want to match mine. So I've got Carlson menus, draw, entity properties, and grading. Give you a minute or two on that. And then following that, I've got inquiry, layers, polylines. Following that, I've got standard, surface, and transparent point commands. Now, let's talk about where they live. Up here at the top, I've got this standard, surface, Carlson menus. So I've sort of put these in, they normally just float. Like they'll come down here and they'll float. And then I can push them up. I can reconfigure their size. I can leave them floating, or I can dock them just by pushing them up there and they'll go in that particular case. So I've got over here on the left, I've got a menu that says draw. You see that one, that's that leftmost. And I look at the one right beside it and it also says draw. Well, that's because if I go back to my toolbar setup under Carlson, you see I had draw, but also under iCAD or an AutoCAD you might also have. I also have a layer called draw. So that on the far left is the IntelliCAD draw command toolbar. And on the right is my Carlson draw. And I do most of my draw commands from the Carlson command line because unlike AutoCAD, Carlson, when it prompts you for a point that you would normally click on the screen, which you can always do, it also says point or point number. So if I'm using coordinate points, Carlson points, I can refer to them by number and even by a range of numbers. So if I've got 25 points and I want to draw a line connecting points, 5 through 15, I can just type 5-15 and it does it for me instead of me having to pick. And there's all kinds of other advantages that you can get out of those commands that you can't get out of the standard draw commands. Now, it doesn't mean you can't use the standard draw commands because really at the end of the day, all you're doing is creating a polyline. So you can do it any way you choose. I just find these commands helpful. Okay, so under my IntelliCAD command set, these are the ones I have. I've got draw, entity snaps, and modify. Modify is this far left or far right on the screen, the long one. And those are the standard CAD modify commands like move, copy, offset, rotate, trim, and extend, fillet, different things like that. Okay. And then I don't have any others for Carlson DGN, CNG survey, or iCAD DGN. I don't have any of those out there, just have Carlson and iCAD, and these are the ones I have in iCAD, just those three. Okay, so once they're there, and if you want to get them placed in a different order, I go up here to the right, up the top, and I've got standard. And that has things like new, open, save, print, etc. It's got my undo and redo, all of those kind of things under it as well. Okay. I've got the next one is my layers. Now this is my Carlson layers toolbar because it has things on it like erase by layer. I can hide and show by selection. I can freeze a layer by pick, or freeze a layer by picking multiple layers and then hitting enter. I've got isolate and restore, all of those different things that I can choose very quickly that are normally located here on the view menu in this section down here. Except there's one thing like erase by layer is not here. It's actually up under the edit, erase by layer. Okay. Now, a couple of other things to know about toolbars is when you look at a command, let's say you use a command a lot. And let's say one that I use on the edit menu, it's a polyline utility, and it has to do with removing polyline functions. So I look under the remove polyline submenu, and I see over here, I do this a lot. I remove polyline vertex, which if you did just a standard p-edit command, it's what they call the straighten option, but it gets, really a little hairy there. So let me show you an example there. I'm just going to draw a 2D polyline, either draw 2D polyline or just pick your, create a polyline from your CAD menu, or I'm going to choose it from here. I'll accept these defaults here on and I'm going to draw, Charlie Brown's sweater or Homer Simpson's little hairline on the side of his head, whatever you want to call it. I've got a polyline with a bunch of vertices in it. Now, normally you're not going to have something that looks like that, but this will illustrate the point. Now, let's say, and I'll put a couple of markers in here. I'm going to put a little marker here, and I'm going to put one here, and one here. Let's say I want to remove those 3 vertices out of this polyline, but leave the others in place. Now, if I do that with standard CAD tools, there's a couple things I can do. I can highlight this, get the grips to show, and then if you hover the mouse, don't click it, just hover over the grip, you can then get a little pop-up and say remove vertex. All right, so that does it. In this particular case, it's pretty easy to do, okay, for just those 3. But now let's suppose we had something like this. Let's say I created this guy. Let me give it a little color and line weight so you can see it better on the screen. Let me come down here, turn on line weights. There we go. All right. So let's suppose that I see this polyline that comes up and it wraps around my data, and it comes down here to this point, and then it comes around the curve, it comes up, goes up and over around this thing. But let's say I wanted to sort of straighten it out between the nose point and the nose point, and then come back in over here at this higher point along the edge. Okay. So if I do that by grip editing, look what happens. Well, I got to zoom in here, and I've got to hover, remove vertex, hover, remove vertex. So I keep doing this, until I get that done one at a time. And it's really a pain in the tuchus. All right. So an alternative to that would be, if I'm going to, and I'll illustrate this back up here on this other one. If I do a p-edit command, that's a polyline edit command. This is the standard way of doing it in AutoCAD. And if I select this guy, I get some options at the bottom. Well, I want to delete some of these vertices. Well, AutoCAD's approach on editing polylines is to try to write every possible contingency into a single command with multiple options and even sub options underneath those. Carlson's approach is to write a command for every typical thing you want to do. They've got a command to remove, they got a command to add, they got a, all those different things. Now, if I do this, I don't see anything down here that says remove vertices. The first thing I can do that I see is edit vertices. Okay, so I do that. I get a marker at the start of my polyline. And if I've got a line like this red one, it's wherever that line started. And then to get to where I want to work, I have to advance by this next command, which is the default in angle brackets here. So I can just hit enter. So I'm going to go next, next. And now I want to, if I go to the next vertex, that's the one I want to delete. But notice, even at this, there is no delete command. There is straighten, because what I want to do is from this point to another point, I want to straighten that line. So I would type S to straighten, hit enter. And now it goes into even a third level of the command, and I have to go next, next. And so now between those 2 points is where I want to straighten. And to make it straighten, I have to choose the option that says go. So I say G to go. Boom, there it is. Now to get to the other one, I'm going to go next, again, next. I'm going to straighten again. And then I'm going to go next, next, next. And now I'll type go. And it's now straightened those. Now, to make this happen, though, I now have to type X to exit that sublevel, exit that level, and now it's done. All right, so you can see how that would involve. Now, if I were doing it down here, for instance, if I want to set this one and p-edit this one, I choose this. Well, notice wherever, I don't even know where this one starts. It's some point there's a marker. But if I'm zoomed in here, I'm going to hit next until I see where it comes around, until I get the marker in my screen. Let's see, pick my line. And I'll go next, 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 next. I don't have any idea where I am. Let me see if I can zoom out and see it moving. Next, next. I don't even see it. No, it keeps making me pick the polyline. Oh, I need to edit vertices first of all. There we go. Now let's see, where is my first marker? So I'm going to say next. All right, I see it coming up here now. So it's up here at this corner. I'm going to go next, and I have to, that's the only way I can't jump around. So if I want to go from there over to the other corner, I'm going to say, okay, from there I want to straighten. So I'll type straighten, then I'll next, next, and I got to step through every single one of them until I get up to where I want to go. Let's see, let's go back one to P for previous. And now I'm going to say G to go. All right, so that took care of that there. Then I would exit and exit, and I'd be finished with it. Now, so here's the difference with Carlson's. If you say edit polyline utilities, remove polyline vertex. It wants you to pick the polygon. So I'm going to pick it, and you're going to get little markers that show you where the vertices are. And it says pick a point to remove. Now, you don't have to snap to it. You just have to be closest to that one. So if I pick this one, and then I can jump over here and get this one, jump down here and get this one, even come back over here and get, another one, that kind of stuff. And when I'm done, I just hit enter. Okay, so that makes it far easier. So if I'm here and I do that same approach, I'm going to go to my Carlson remove vertex. Here's my icon, or here's where all my little points are. So I'm going to just start clicking here and keeping an eye on, which ones I'm getting rid of. And say maybe, I went up to like that. All right, so when I'm done, I just hit enter and I'm done. All right, so it's a real handy way, and the same thing is like edit polyline utilities. Edit polyline, and I want to add a polyline vertex. I do the same thing with that. I can just pick, wherever's my nearest point, or I can at that point snap to say that endpoint and then snap up. Let's see, let's leave it at that. Here's another little tool with grip edit. If you select this and turn this and hover over the mid section of a 2D polyline and that grip, you can convert it to an arc, and you can make that a true arc segment instead of, point, 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 point. Okay, so there's a number of really cool Carlson polyline editing tools that can get you a lot of increased productivity without having to go through all the various methods, but you can use any of those. You can also do things like simply break. So if I'm going to choose the standard break command, I'm going to break this polyline. I'll type F to give it a first point, and I'm going to snap to there. And my second breakpoint will be over here, let's say. So now I've broken from there to there. It's now out. And so I would have to draw a 2D polyline, and I'm going to pick that to be where I'm going to start drawing. And I'll say, okay. And I can either snap to that point, or I can type C to continue, and it adds to it. But I'll just go from there up to there. Now I've got that. It is on the same layer, boundary 10, but the color is by layer instead of red, which this one was set to be red on that same layer. But now I have this polyline, and I have separately this polyline. So what I would need to do is edit, join nearest, and I would tell it to directly connect the endpoints because they're already connected, but you can see you can either average the two endpoints, or you can fillet the endpoints with a radius of 0, which means basically if there's a gap in there, it will extend each line to where they meet. And then I would say, okay, and I'm going to pick this one and this one. And when I do that, it joins it all back together. Now it reset the color back to bilayer. I'll put it back to red, and I'll put its weight back up so you can see it. All right, so those are a number of different editing tools for polylines, but what I was starting to tell you about was how to make these a little more efficient than having to go edit, polyline utilities, remove polyline vertex. So what you want to look for, if you find yourself using a command quite a bit, look in a couple of places. First of all, look down at the very bottom status line of the screen where it says what the command does. Removes the user specified vertex from a polyline, and then it gives a colon, and then it gives the name RMVERTEX. That's the typed command. If I type that at the command line, it's going to give me that same command as if I chose it here or chose it from a toolbar. But the other thing is, if I see, and you can see some of these commands have icons to the left of them, and some do not. So in this particular instance, the remove polyline vertex has an icon, and it shows a polyline, and it shows a pencil eraser sitting over a red marked vertex. The one above it says remove a polyline segment, and that takes out the entire segment that you pick, and it shows a pencil eraser over a red indicated segment of a polyline. So they both really show you what they do. But the key thing is when you see an icon next to a command in the menus, that tells you right away that that command also lives on some toolbar. It doesn't tell you which, but it tells you at least that if it's something you use a lot, you might want to investigate your toolbars and figure out where it is and what it does. Now, a couple of things that you can do with that as well is, let's go to my help menu, look at my Carlson help, and let's search for RMVERTEX. And right there it is, remove polyline vertex. If I double click it, notice it tells you a couple of things. It tells you where it is on the pull down menus. It's on edit, polyline utilities, remove polyline, and it tells you the command. So that's another way of doing it, just like we saw down on the status bar once we knew where it was in the menus. Again, it still doesn't tell you that it's on a particular toolbar. The only way to figure that out is to sort of look at your list of toolbars, like here, and you see that there is a toolbar that I have up and going called polylines. Well, that seems to indicate maybe there's some polyline tools, and that's this toolbar right up here. And it's got various commands. There's extend by distance. There's a boundary polyline, which is different. It's a standard CAD command. There is join nearest. There's reduce the number of vertices, or in other words, weed out the extras. There's to densify or add extras in every so often, smooth it, close it, add a polyline vertex, add intersection, and there's your remove polyline vertex and remove polyline segment. So if I choose that remove polyline segment, for instance, I just pick a segment and it takes care of doing that. If I choose remove polyline vertex, it does the very same thing that we did before. So I can now go in here and get rid of this one, and this one. Okay. So look for those icons and then try to figure out maybe where those commands might be. If you find yourself using these a lot, try to figure out where those commands might live. Now, there's other things on here that don't come out of just that menu, because there's things like edit, join nearest. That's also up here. There is extend by distance right here. So that is also up here. And there's things that are not there, like extend to intersection. That would be, how you would do that normally. Let's say if I've got another polyline here, and I want to extend these to where they intersect, there's a couple of ways of doing that. If I, well, you can even do it with a grip edit, as long as you are, see how that line comes up? So that's going to be along that line, and I'm going to hover over here and get that one. I'm going to come down this line, and right there's the intersection point. So click there, and then I would go back and grab this grip and bring it down and just snap to it. Okay, now notice when I'm snapping, if you're not familiar with snapping, I've got an object snap setting where I've got my endpoint. It's automatically going to find endpoints, and I've also got center, midpoint, and extension. That's where you saw those green lines extending out. So those are the ones that I'm going to run with my entity snaps. I also have up here my entity snaps toolbar, where I can temporarily override those things, and it takes effect for just that one command. But these are the ones I have normally running all the time. Now, so that was a command that I can use. I can also use join nearest, and I need to pick a distance that represents the at least enough to cover that distance. So that would be 139 and a half in terms of a distance there. And when I do that, I can fill it with a radius 0. Okay, and so if I do that, though, join nearest is actually going to connect that into the same polyline instead of just extending to the intersection. So if I say okay, and then just pick those two, I must have missed my distance. Let's see, that should fill it with radius 0. Why is it not? Let me see, am I on a different layer? 110. Ah, that's why. It's not on that same layer. So I'm going to match, use that, and I'll match that. Okay, that's why. And the reason that didn't work on this near join was because I had down here join only identical layers. So that's why that didn't work. So now if I do it, you see it extends, but it makes it all one entity. So if I want to extend it to where I have, where they meet at the intersection, I can either do that if I want to join them together, or I could do that grip edit technique that I was showing you about, where I come down that extension and I have to hover there to get it, and then do the same thing. I could do that. Or I can use a standard fillet command, which is edit. I don't, oh, here it is, fillet, which is also over here on my right-hand toolbar. You see this icon right there. There's the command fillet. So if I fillet that, notice the options down below. It needs a radius value. Well, if that goes to the intersection, the radius of that curve is going to be 0. It right now tells me that my current radius is 0. So I'll take that and I'll pick this entity and I'll pick this entity. Okay. Now, when you do that with a fillet command, it also joins those things together. Okay. Although I think you can control that with your settings here. Remove corners. No, apparently what it does is it still puts those together. So if you, let me see, maybe it's under trim. If you say no trim and then do it, let's see. Trim says no trim, radius of 0. No, it's not gonna. I was trying to figure out a way to make it work, but it's not going to let me do that. Okay, so that also does it. Or I can extend to intersection, and I'll pick this line and I'll pick that line. And now it does that, and it keeps them as separate entities, but extended them to where they would intersect. Okay. If I do need it to be a standard, if I need it to be a single, I could just do a join nearest and just select those two, and now it's together as a single one. So any number of ways that you can do that, that just might make your life simpler. And one of those that we do is that RM vertex command, but it's buried really deep under here. So I'm going to make sure that I know where that lives on a toolbar. Now there's also something else about that, RMVERTEX. That's a little much to type. What if I wanted to just type RV to remove vertex? There's under settings, this thing called quick keys. Okay. And this lets you create any number of, you can give it a command, and right down here, I've actually put this one in called RV, and I gave the command, and it's either going to be of the form parentheses C colon, and that does not mean the drive C. That means it is a Lisp command, a Lisp routine. So C colon, type the name of the command, close the parentheses, and that's going to be that command. So that's going to be RV. It can either be in that form, or you can see, for instance, here's a zoom in. So if somebody wanted to use ZIN to do a zoom in, so you put in the underbar period zoom, and that means it's a particular, it's not a Lisp command, but it is an extended command that is part of the ARX development kit under Carlson, or under the AutoCAD system. The other form that these things could take would be just simply type the command like this, twist 2 and twist 1. And those are the built-in commands as part of just standard AutoCAD commands. Now, I don't know how to tell you which ones are going to be always applying because I don't know the underlying coding of the system. So what I'd recommend is when you create any of these, you put in what you want to call it. And where it says over here where you type in the actual command, try of those different forms, either parentheses, C colon, the name, close parentheses, or underbar dot, the name of the command, or just the name of the command like these two up here. Try and see which ones work, and that'll work. So now RV is set. So if I type RV at the command line, see, it says select the polyline to remove from, and I just select that, and there's my little temporary markers. Now, if I zoom up here, those blips go away, and if I get rid of that one, they'll pop back up, and they stay there until you change your view level. So if I get rid of this one, those two, maybe like that, and then if I zoom back out, and we'll click near that one, see they pop back into play. Okay, and maybe get rid of that one too. All right, so those are a couple of things about your toolbars, about your commands, some ways to learn these and where they are. Look for those icons and then try to figure out what toolbar they might be associated with. If it's a surface editing tool, I would look under my surface toolbar, which has triangulate and contour, contour from a tin file, draw the triangles, edit the contours, smooth the contours, elevation labels, all of these different things you can do. And quite frankly, the only ones that I use on that whole toolbar is the triangulate and contour command, the view, the 3D viewer window, or the surface file viewer, which is really the same viewer. And, you know, all these others I typically do just from the pull downs. I don't generally use them so much that I need to grab them here, but that's just a matter of preference. Okay. So that should give you a sense of, you know, what my layout is here. And if I choose something from some of these and I go too fast, make sure you let me know. But here's one that I use quite a lot of, is on this layers command. These two here, to isolate layers, to restore layers, also to freeze by pick or just freeze layers where I pick multiples, and erase by layer. I do that quite a bit. Okay. And that lets you choose particular layers. Like if I wanted to erase only these obscured contour layers, if I choose that erase by layer, for instance, I'll clear out this list. That list persists between commands, so make sure you clear that if you no longer need those layers. But I'm going to select layers from the screen, and I just pick one example of the given layers I want. So I'm going to take that yellow one, that green one, and say this white one up here, these break lines. So now it has identified the layers. It's placed them on here. You can type the layer name separated by a comma if you want. And then you can also limit what gets erased or choose all. And if you say, okay, now they're gone. So all the white ones are gone and all the obscured ones are gone. Okay, so that lets you do some things pretty quickly at a, you know, at a full layer. Instead of having to, some people would do this, they'd isolate layers. They'd come down here and they would pick this and this and this, get only those things showing, then they would select this and hit delete, and that would do the same thing. And then once they're done, let's say I deleted those, and I will come back here now and choose restore layers. And so that puts them back to where they were before, okay? I just undid everything back to where it was. All right, so any questions on any of that? Everybody maybe get some good utility from that? Now, a couple of other things to help you identify, particularly to get ready to model. We have a switch that we set in our settings, Carlson Configured General. that said right here, ignore zero elevations. And what that means is when I go to model my surfaces, I want to be able to select all this data. But if I look like this, I've got some data that's down here at zero elevation. Well, I don't want that to be included in my modeling. So with that switch on, it's going to, even if I select it, it's going to ignore it. Okay. So it's a nice handy switch unless you happen to be working down at sea level where sometimes things with a true zero elevation could exist, and you just have to be a little more careful in what you select. But Josh, for instance, I know you're not down at sea level. Ryan might be, you're out in Oregon, but who knows? Um, Usually we don't. And even if you're down at sea level, usually things have a somewhat of an elevation, like a 0.0 something or other, instead of exactly zero, but you would just want to be careful with that if you happen to be working in those environments. Now, let's see, where was I going with? Oh, another way to be able to recognize these things, let's say, I do this or I do this little zoom up issue, and I assume that these things are down at zero, but maybe they're not. Maybe they're at like 0.05 or down at, maybe even something like minus 200. Let's say, maybe this one, let's give that an elevation of, let's just say minus 10. So we don't really see it. It looks to us like it's, down at zero. Okay, so here's another quick way to help identify things that are correct in your surface. So I look at this and I see I'm about at elevation 1300. Okay, so in my initial exploring of my file, I'm going to look here under File, and I'm going to choose this command called Drawing Cleanup. Now, this lets you do all kinds of things to your drawing, and you can read these. You can convert the coordinate system back to world coordinates. You can remove any duplicate line work. You can remove duplicate text. Maybe they're on different layers. You can remove overlapping loops. You can join up line work with the same endpoint. So maybe all your contour lines have been exploded and you might want to join them up with the same line. So different things you can do. There's a defaults. This is what the programmers have decided is good to have as a defaults, or you can clear everything. But in terms of the elevation exploration, one of the things that I like to do is I hit the clear button, and then I'm going to only turn on this bottom one that says set elevations outside a range to 0. Now, be careful of this before you hit OK, because whatever's in these boxes means if it is below, or if it's anything that's lower than minus 1,000 or higher than 20,000, it's going to, instead of erasing that entity, it's going to set it to 0. Well, that's fine. That may be from something else from a previous setup, but I want to make sure I hit this scan drawing button first. And so when I do that, all right, and notice the line that I set down at minus 10, it identifies it. Well, I know I'm up at around 1300 in terms of my elevation, so I see my highest is here. So maybe I'll bump that up to say 1400. And I would assume that I don't have anything, much more than 100 feet lower than that, or maybe 200. So let's just maybe even just bump it up to 1,000. So anything lower than 1,000 or higher than 1400 is going to have its elevation set to 0, whereas it doesn't erase it, it just resets it to 0. So I hit OK. It does its thing. It tells me, okay, I set one entity outside that range to 0. And so now I come back and if I select that polyline, I see that its elevation is now 0, and I can then deal with it. If I have to give it a different elevation, maybe it should have been at 1300, but it was at -10, then that lets me identify it. And then I go back and I make the edit to that entity to do what it is I need it to do. So this comes in really handy, particularly, Josh, you might run into these when you're dealing with large areas. I had a client out in maybe either one of the Dakotas. It might have been in Montana. I don't recall. It was big coal country. And anyway, he was modeling something like 2 quad sheets worth of data, or maybe more. It was 30-some thousand acres that he was trying to model. Well, he'd run his command to model to make a surface, and it would come back and it wouldn't give him any errors, and he never saw they had any errors until he needed to go and view that surface in 3D, and he noticed in one particular corner of it, he had these things that were like way up in the air, like 40-some thousand foot elevation. And somehow or another, when he was converting his quad data, the elevations got screwed up on that one corner. So he could have used that drawing cleanup to identify those and then set those to 0, but then he'd have to go back and put them at their proper elevations. But at least he knows where those problems were coming in, because he was getting some ungodly coal reserves, as you can imagine. So, something up at like 40,000 feet. And but the computer very blithely modeled the surface and created it without any errors, because there wasn't anything that actually triggered an error. It was there if the data was correct. So that's one thing we want to always be aware of, is all these little tools like that, is to use drawing cleanup to investigate different things. And sometimes you'll have things like, if we explode, I'm going to explode these 3. And so now you see, when I pick this, I've got individual line segments, even though they should be drawn individually. Well, if I don't want to have to go through and do a join nearest and pick all of those segments together, I can do that as well with that drawing cleanup, where I can say, let's just clear this, and I'm going to say join line work with the same endpoints. I'll say okay. And it says, okay, I joined up 292 different line work entities. And now you can see they're back as individual entities. Okay, and they go over here and join to another contour, which is actually part of the obscured contours. So it's a nice way of putting those together, if they're pre-built and you don't have to run through that. So a number of little editing techniques. Another good one that is often used is to remove these duplicates. Any points, any text, any line work, and you can give a tolerance so that if it's not exactly duplicate, you can give it a particular tolerance value. And say within 100th, I can do that. And I don't think there's any situation like that. Oop, it did have 27 duplicate points and 1 duplicate line work. All right, so that's a way to get rid of some of that additional information. All right, so keep that command in your hip pocket. It might be useful for you. Another couple of ways that you can help to identify some of this stuff is a command. If you're not, let's switch to the civil menu. So I'm going to go to settings and choose my Carlson menus and choose civil menu. I was already there, or you can take it from the toolbar, which you see right here. Right there's my civil. And now under the profile menu, I have a quick profile. I'm just going to do a quick profile. And you've got different choices. You can say use screen entities or 3D polyline. And if you did a 3D polyline, you would pick one of the 3D polylines and it would create the profile of that polyline. But I'm going to say use the screen entities, ignore any zeros. And you can also choose a single surface or double surfaces. You can see those plotted, and we'll do that later on after we get into our modeling. So I'm going to say, okay, and I'm just going to strike a line from here, and let's just go across the roadway like this. And I can keep going, but I'm done. I just want to look at that one line, and you can see it marks you where you were. Okay, and you can see now, and it'll track, and you can see what those are. So every time it hits something up here, you can see down below in the profile where the tick mark is, like right there is on the top of that line. There's that white line it crossed, and I'm going to come down here and it's picking all those individual ones. Then it comes across the road. Now this is just intercepting the drawn elements, and it's assuming straight lines in between everything else. For instance, if I freeze off, I'm going to freeze by pick. I'm going to freeze off these break lines. Now, if I do that quick profile, and if I look at this now as I cross, I'm going to go from here and I'm going to cross like this. Now, notice where I'm crossing in relation to that contour line. Okay. So I pick my point. I'm looking at where I am here, but now look at, I know from looking at the contours that when I walked in this line, I should come down here and go down a little bit and then come back up to reach that. But when I look at that from here, see where my blue marker is in the profile view? And I go across to the next one, you see it stays the same elevation, goes all the way across here, finds it again, so it's still flat, but see, it should be dipping down right in here, and it should be raising up right in here, and then dipping down again in here, and then it starts to pick up and follow these lines. But when I'm doing screen entities, the only thing it's getting for information is the things on the screen that intersect that line. Okay, so when we model it as a surface, then it's going to fill in that information in between because it's reading triangles instead of the drawn entities on the screen. But it's a nice little way to sort of help you identify, make sure things look the way you expect them to look, and go from there. All right. Questions on any of that stuff? All right, let's talk about our modeling. And we're going to go here to this important concepts in our book here. And we're going to talk about, and down here to page 18 under surfaces and contours. And right in here, and I'm not going to read this to you or take the class time for you to do all that, but the this is really the gist of what's going on. And we're going to be developing this model, this terrain model, because we're going to read information in the drawing that has elevation, and we're going to look around it and find other things with elevation, and we're going to then connect edges up between where we're sitting and what we see around us. Okay, to it. And when we do that, we're going to draw a line between where we're standing and the next thing we find available. And that becomes an edge of a triangle. Now, the reason we use triangles is because it takes at a minimum 3 points to represent a planar surface. So every 3 points will form that triangle, and it makes a little, when I say flat, I don't mean level. I mean it's in the same plane, a little facet or a triangle, or what they call a polygon, that when you put that together with the polygons that adjoin it on those 3 edges, and then you go to those edges and stitch together all of those adjoining triangles, then together they form this unbroken whole fabric of what that surface is supposed to look like. And that allows you then to query the blank spots in the drawing, say between contour lines or elevated elements, and find out what the elevation is on the ground if it were built according to the way you've made the model. Okay. So a lot of times we can, we can look at these, say this polyline here, we can look at that and know that, in between this polyline and this contour line and the contour line above it, we know in here this is less than the one that's highlighted, but it's higher than the one below it. Likewise, when we come across this way, we know that somewhere in here, we should be about halfway between this elevation and this elevation. So it's when it starts to form those triangles across here, it then knows, because they become 3D edges, it then knows when I click on a spot out here, it's going to read that triangle and tell me what that elevation is based on where it intercepts that triangle. Okay, so we can look at contours and we know inherently that this elevation is lower than the contour line. This elevation is higher. But if we don't have that into our model, the only thing the computer is going to know about is where that contour line is and where the other adjoining or neighboring contour lines are, and it knows nothing about the empty space in between. That's why we have to do this in terms of modeling. So that's all going on with this discussion. It gives you a little background and talking about contours. And, said, ask any surveyor what contours are and immediately know. We've learned over years exactly what it is. But, ask a stand-up comic what a contour is, and he'll tell you that it's a travel agency specializes in vacations for inmates, blah, blah, blah. But we know what they are sort of inherently based on our education. But again, we need to model the space in between some of that information. And up in here on the other part of our discussion, we're going to be using this process called triangulation because we have those 3 points that make this little plane segment in space, combining those resultant planes or facets edge to edge, and that brings up that entire thing. And that's why you hear the term a triangulated irregular network, or TIN, we call that. And it's because it is a network of triangles that are irregular in shape. Therefore, it's a triangulated irregular network. Whereas in contrast, Josh, a grid file is the same type of thing, but it is formed by regularly spaced grid points. And so it uses those to compute what the elevation is in between. It just interpolates along those edges of the grid. Okay, so that's what we're going to get. And you're going to see a file called something.10, whatever you name surface, and that is your surface file. It lives external to the drawing, and you can load and unload different files. And if you remember when I looked at my viewer and I loaded up that existing ground surface file, that was actually not in this drawing itself. It was over in another place where I did it another time that I loaded it from. So that's the advantage of these external files. They don't have to even be in the drawing. They can be things I can just pick from other places. Now, here's the key concept. Every triangle edge that forms, it's understood to be a line of linear change, meaning it has a constant rate of change in elevation between the two endpoints. And so if these 2 points are not lying along a straight line changing grade, you have to separate them either by another point where it changes grade or by a break line that crosses that change in grade. Now, if you're not familiar with the term break line, all that means is, and they used to tell us in college, that a break line is a line along every breaking grade. Well, that didn't really explain it to me all that well for me to remember when I was learning this kind of stuff, but I'll tell you a way to think about that here in just a second. Is so how they come into play is this. Every point that you can see, and when I say that you can see, I mean if you're sitting on a point, like down here in this figure, maybe I'm in this lower left point. I look all the way around myself in a circle, and every other point that I can see, as long as there's nothing in the way, then that assumes I can create that line of constantly changing elevation. In this particular example, those two lines happen to be the same elevation. All right. And if there's something in the drawing that is already drawn in the way, that's going to prevent me. Let's say I'm over here on the lower right point. I look around myself. Well, I can't look over this edge and see this point in the upper left because there's something in the way, and that would be my break line. Now, if I didn't draw that break line in, what happens is if this triangle in the upper left gets formed first, and all this happens in memory very quickly. If that triangle gets formed, then this edge exists. So this point in the lower right can no longer look up here and see this point in the upper left because the triangle had already been formed, and that keeps that from happening. All right, well, that's well and good, except I don't know which triangle is going to form first. Okay, so we're going to figure out when and where we need to have some break lines. But instead of trying to remember that there are lines along areas that have a break in grade, the actual thing that you need to remember, or the only thing that you really need to remember, is this right here on the next page. If a break line is nothing more than something that represents, let's see, in fact, it says right here, there are edges in the surface. So if it is an edge on the ground, now what are an example of an edge on the ground? Maybe it's the gutter line that flows down the face of your curbs, or it's the top of the curb, or it's the back of the top of the curb. So all of those things represent edges, and those are the ones that we need to have as break lines in our data. So you don't even need to start, spraying in thousands of points to survey those things in and get the points all close together and hope they connect. You can just get the far end points, and as long as you draw that line in between those, that will then serve as that break point to keep this from happening. Okay. Now, here's why they're important. Let's come back a page here now and go back, look at this similar little discussion. I've got 4 points. I've got the two northwest southeast points are at elevation 100. The northeast southwest points are at 110. Now, the way this is modeled right now with this little diagram is I see that it formed the triangle such that I've got a straight line of elevation at 110 feet from lower left to upper right, and I've got 2 points left and right of that line that are down at 100. So that would be, if you can visualize that, that would be like a little ridge line at 110 feet, and it falls off to the left down to 100. It falls off to the right down to 100. Okay. Now, that's the one instance. If I go to this instance, very same points, 110, 110, 100, 100. If the triangle's formed this way, I've got a little valley floor or a ditch line or a stream bed or something along this elevation of 100, and it has points to the left and right of it that rise up to 110. So you can see that would form a completely different feature on the ground than if I had the contour, if I had the triangle edges formed the other way. And the only way to control that is for you to tell the software, hey, these 2 points need to be connected. That's why you'll see some things in a survey file, for instance, that might be a line, and they'll mark it as top of bank and bottom of bank or something like that, so that the points on one side of the top of the bank can't look down through the ground and see the other points down, say, at the bottom of the bank. It needs to find only up until it can't go any further, and that's where it hits that break line. All right, so that's what we need to sort of keep in mind. Now, we're not going to be doing a whole lot of adding break lines unless we need to. A lot of times the data we get's already done for us. But here's a here's a good real world application of that. Here's a curb structure. And let's say the surveyors went out there and got us these points. So I've got A and B along the edge of the pavement, C and D are along the gutter line, E and F are along the top of the curb, and G and H are along the back of the curb. Now, if I don't draw the lines in between those points and I just turn it loose to model, I could wind up with something like this up here, where these triangles are going to form. This one's legitimate, A to B. A goes down to C, comes back up to B. So that triangle is fine. It lies in the plane of the gutter. What about this triangle? A jumps all the way up here to E and comes down to C. Well, A to C is fine. E to C is fine, but it doesn't do this. It needs to come over here and then up. Okay, so, but I don't have anything that prevents A from seeing E. So it formed a triangle there. Same thing here with G and C and F and B. Okay, so the way we fix that is before we model it, we draw in those edges. And so now A can no longer see E because there's a drawn line in between it, but it can see C and B, and that triangle is legitimate. And it would make this triangle here adjacent to it based on whatever next point it finds. Maybe there's another point down here. Same thing. So you see what's happened is when we draw the edges, now we've got this EGF triangle and the ECF triangle. One's on the top of the curb, one's down the face of the curb, and those are fine because C can no longer see point G, or G can't find point C and put a line connecting them like it did over here that goes through the curb face or goes through the curb structure. It forces those triangles to lie along those planar segments, those surface edges, the surface components. Okay, so that's what we need to be aware of, is when and where we need to use break lines to control how those triangles are going to be formed. And so basically, if you remember, if it's an edge on the ground, then we need that edge in the drawing to model the surface. And, because a lot of times when we do model the surface, and if we don't have those edges, sometimes the triangles form correctly. We just don't have any control over it. And there's no real way of knowing that outside of understanding in depth what's called Delaunay's criterion, which is what it uses to compute those triangles. And it's very complex mathematically and not even worth going into the discussion over. However, so that's going to be what we're going to use, is to figure out where we draw the break lines. And remember, if a break line is drawn, then that's going to prevent a triangle edge from crossing it. It can run along it, but it can't cross it. So that's what we're doing, is we're putting up barriers where we see those lines. You'll sometimes see those termed faults. Not sure exactly where that came from, but just in earlier days of the software, it used to be called fault lines. It's not really an earthquake, but anyway, it's an edge. So you're creating these edges. So if you draw them into the data set, and you're creating barriers that prevent those invalid edges from forming, because points on one side can no longer see the points on the other. All right, so that's what we're trying to do. And we need to know when and where we need to do that. So in the case of our 4 little points up here, if it truly is a valley, we need that line to connect those before we go to model it, so that 110 can't look across and see the other 110 and form a triangle there first. Okay, so that keeps that from happening. Now, sometimes, like I said, people like to edit the resulting triangles, and they'll see something like that, and they'll do what's called swap triangle edge, and they'll select that, and it'll flip it to where it goes this way instead of this way. And whereas that does accomplish the same thing, if you go back and have to recreate the model or do something to it, and you don't want to try to look at every adjacent triangle and try to figure out when and where you need to switch to swap those edges. So it's easiest if you understand this rule right here, that if it's an edge on the ground, you need to make it an edge in the data. Okay, now it's just a matter of drawing a 3D polyline between those points and connect those up. All right. Now the rest of this discussion is going to be talking about, how we turn this into a model, what you sometimes see a digital terrain model or a DTM, and we're going to make it as a TIN file, and then where we can get various sources of data, either things downloaded from state level GIS systems, stuff like that. You've got other things, digital files of previous processing, files of elevation data like this little grouping of X, Y, and Z coordinate values that are going to create that we can use. They don't have to be in the drawing. We can read that information in. But right here, and again, there's that little notepad icon that says, take note, this is important. You have to evaluate this data and look at it and see if it actually is representative of what you're trying to model. Most times it is, but you need to look at it. And there's various ways. You saw us use that quick profile. We can do, look at elevations and get a sense of it from the modeling. But the easiest way to do it is to look at it with our eyes. And that's another tip over here. All the data you want to use has to be at the right elevations, and it's easiest often to simply look at it from a different angle. In this case, I've tilted it up in 3D, and I see in this case, in my good data, I've got these road edges. They're all along where they're supposed to be with elevations, but I look at it over here, if I spin it up and I see, well, somebody drew the roads in down here at 0, and all of this other data is okay, but these are going to cause a problem. They're not going to serve as break lines like they do up here correctly, even though they're drawn, but they're not at their elevation. So they're going to allow points on, say, this little road cut right here, say a point up here can look across the road and connect to a point over here. If we were like this in, let's see, where is that? It would be up in here. Up in here, it's a little fuzzy out of focus from a different perspective. But so if we don't have these lines drawn at their elevation where they're supposed to be, and if they are, then that keeps the points over here from jumping the road and finding these points. It has to come down and find points along that edge, and from that edge to the next edge, that edge to the next edge, et cetera, et cetera. Okay, so it's not something we can see in plan view. Here's an example of it in plan view. You don't see that. You don't see that there's a problem. So we just spin it up and say, aha, this is going to be a problem. I need to make sure those things are elevated. And we have tools to do that with. Okay. Then you've got some other potential problems, how to resolve them. Things like these extra little triangles out here in this little in-cut part of my data set, which means when I ran the triangulation and got these triangles, it is telling me that, okay, the ground goes from here up to here along this, continuously sloping triangle all the way around here. But really, we don't know anything about the ground in there at all. It's not in our data set. So we can either erase those triangles with a direct edit, or we could put a line around the outermost edge of our data to serve as a break line or as a boundary, which in contrast to just a standard break line, boundaries can be 2D because they will cut off these triangles regardless of their elevation. So we're going to think in terms of boundaries when we make these data sets so that that doesn't form. Okay, and so we have some tools to do that, like this shrink wrap entities and all of that. And again, we just evaluate, evaluate, evaluate. And right up here then is the key point. Use your eyes, okay? And think about what you're looking at and what you're doing. And is it going to be the best for whoever's going to pick this up from after we do the modeling? Okay. So we're going to run through some exercises and how we do all that. We've already started to see some of this stuff in our data set from the photogrammetrists. And let's take a look at some potential errors. I'm just sort of stepping through this that I can leave for you at your own leisure. We're going to be doing all of this, not necessarily in that stepwise order, but we'll take a look at it and see. All right. And then we'll look at some tools that we can use with this 3D viewer, and we're going to really get into learning how to use that 3D viewer. Okay. So back to our command set. If you have not done so yet, or if you don't still have it open, go ahead and open that file called sample from T3 Global. And I'm going to turn back on all of my layers, and we're going to look at some different things as to what we have in our data. Now, what I'd like you to do is, for right now, let's freeze off this layer of these little random looking white lines. So on our view menu, we're going to choose freeze layer by pick, or we choose that from our toolbar. And let's just go up here into this corner, and
Sorry to interrupt. I don't have a sample from T3 Global.
it should be in your data set that you got in the download. When you had the link where you got your
A lot of stuff. I don't see that one in here though.
all right, what do you see? Can you share your screen with me?
Oh,
If you go down to your controls, go to the share button and choose the screen.
is it showing?
Yeah, one quick second. Let me see. It might be behind. Yeah, there it is. All right, I'll bring it up. All right, so if you go to, so you're looking in Carlson projects, you see up there at the top, you want to navigate to wherever you put the file called, no, that's not. So if you go back to open, now I see your hummingbird. I don't see anything else. Let me, I'm going to request remote control. You have to give me access. Okay, now, when I look at this file right here, so I want to open this file. Now, where it comes up by default is in Carlson projects. You see right here? But
Okay,
that's not where I want to be. I want to be, where did you save
it's on my desktop.
on your desktop? So let's just go to your, wherever it is. That's drive C. Oh, here it is, desktop. So there's your Carlson Civil Training data sets, and should be right there.
Okay, thank you.
You betcha. All right, so I'm going to, let's see, I'm going to stop my remote control, and I'll stop your share, and then I'll share mine. So now you should be back to seeing my screen. Everybody see that okay?
Yeah.
Okay. So once that's up and going, we have all of this data. So we're going to freeze off that line. So I'm going to go to view, freeze layer by pick, and I'm going to turn off those white lines for a minute. Okay, and so we're going to take a look at this in our 3D viewer first of all. So we're going to choose View, 3D View, Drawing Viewer. Notice down at the bottom it tells you what it does, and it has a command called Cube. So you can just type Cube and hit Enter, or find the toolbar where that's on, and you can see it's right up here on my Surface toolbar. But I'm going to use my Drawing Viewer. It prompts me to select the entities. I'm going to select them and hit Enter to conclude my selection. And now I can see a couple of things here. I've got a switch up here to ignore zero, and if I uncheck that, I see the zero elevation items, although they are not exactly underneath because you're looking at a perspective view. So it's shrunk down and sort of set inside because you're looking down on the floor from a height. All right, so I'm going to ignore my zero elevation. So this is only what I would see in 3D. Now notice these points show up. They're nice and big so that I can see them, whereas before out in the drawing, they're set smaller so they don't show up very well. Now, here's what I want you to do is we're going to learn how to navigate our way around in this. Over on the right-hand panel, you've got 3 tabs that control the viewer, and the view control is where we're going to set a lot of this stuff up. We are going to be able to set an exaggerated scale if we want to, or leave that at 0. Now keep an eye on that, because if you say run this up to say a 3-time vertical exaggeration for a particularly flat area, it's going to stick between times you run this viewer, even if you switch to a different file. So make sure that, if something looks weird, that you sort of keep track of that. Okay. Now you can do another way of looking at your data in color is with this color by elevation. And you can see a little range on the side, and it tells you that you've got 1280 up to 1341. So that's the range, and there's your color spread. So your low spots are blue, your mid spots are green, your red spots are red, and you can set those colors over on the settings tab if you like different colors. But this is another way of, just like we did that file cleanup and we looked for the elevation outside of range. If we had something like this, I'm going to exit this. You don't have to do this, but I'm going to put this guy in here again, and I'll set him at -10, like we had before. And we'll view that. And now, even though I'm ignoring 0, I see that, I go from down here at negative, it looks like it says -9, or it's -10-ish, up to my 1340-ish. So that's good, but it shows me as everything is being red except for that one blue outline, and it's there, and it's at -0. So that shows me that something is out of whack. And if I double click it, I see that it found what layer it's on, and I can set that 0 elevation. Okay, so now I've set it at 0 elevation, and it should have set it once I come back. Yeah, see, it set it to 0 elevation. And so the thing is, you have to get out of the viewer and back into it before you see that effect. So now when I look at it, I'm seeing it's no longer being seen because it is ignoring my 0 elevation entities. All right, so that's, if you look at this elevation by color and it's all one predominant color and you don't see a good mix of low to mid to high, you've got something you need to investigate. Okay. That's how we found that Josh, that guy out in his multi-county, he had this corner of his data set was like all red, and everything else was blue, or whatever color we were looking at. So we knew something was wrong in there, and that helped us find where that was. Now you'll see if you watch any Carlson YouTube videos, every time they look at a surface of stuff, it's almost always showing you that color by elevation. They seem to love that as their default way of looking at things. I'm the opposite. I like to see the colors that they are in the drawing. I can set that here, and I can even do things over on my model tab in my different list. I've got my layers where I can say that V topo major, maybe I want to set that. I'm going to right click and set the properties, and let's set their color to say red. So now I can, identify different things. Now that doesn't change the color out in the drawing, just for the viewer. Okay, so you can do some pretty nifty little things to help you visualize what's going on. All right, so now here's how we work in the viewer, how we rotate our way around and that sort of stuff. There's a couple of things. You've got this little thing here that doesn't have any effect when we're looking at drawn line work, only when we're looking at 3D solid objects like the triangles of a surface or the pipes in a pipe network or something. But this lets you set the position of the lighting, and think of that as the sun up in the sky, and it casts shadows, and then you can control the brightness and contrast and stuff with these sliders. These icons that show the little magnifying glass, you could really just forget about, because your wheel on your mouse does that kind of thing. Same thing with this pan hand icon. You could choose that and use it to pan around, but you don't need to. Um, you can just, use press and hold the wheel on the mouse, and it does the same thing. But now these bottom choices are going to be, in this case, the one that looks like a fishnet with the colored in squares that says toggle the shading of surfaces. Now, again, we're not looking at a surface. If we were, I'm going to go to the model tab, and I'm just going to add up a surface that I looked at earlier. Yeah, looks like now we're getting the file open lag that Zoom puts on this thing. So bear with me just a quick second. Good heavens, come on. Now it's probably going to exit because I clicked over that icon. Yeah. Anyway, what that is if you have, yeah, see, it exited the viewer. Okay, maybe not. All right, here we go. So if I look at where I was here in hydro, the existing ground. Oh, so sorry. Uh, actually, the wrong file. Um, in fact, this is going to be like way out into this area in here. No, that's my data. So it's somewhere else. I'm trying to see. Let's see the one. Well, let me exit that and come back into it. I got the wrong data file. All right, so we'll go back into our viewer. And we'll go back and now add it as surface. And this time, let's go to another civil. See if I can find the right one. Let's see. And in there, let's look here. Stockpile, nope. Let's find. Not there either. Here we go, EG. Yeah, there it is. See, that little preview showed me the outline of the surface so I could see it. Now I've got that surface loaded. And so now this little toggle, you see how it turns on and off, because those are called, surfaces, or sometimes you'll see solids. And that's just a way of, if you're looking at something and you want to see it as colored in, you just turn this on. And there's a setting for that under settings for your shading sides down here at the bottom. Say just shade the front, for instance. So now I'm looking at it, but if I go up underneath it, you see it unshades it, so you know you're turned the wrong direction. So that's a couple of those settings that you can use to make sure uh, you're visualizing what you want to visualize. Now, once that's done, let's say I'm doing this, and we'll look at that in a minute too, but you notice this, see how I can change the lighting and get it to cast shadows in different directions, because sometimes, and we as humans, based on advertising, believe it or not, where we always see drop shadows down and to the right, we're used to seeing our light source up and to the left. And so if we take it down and to the right, for instance, and maybe up the brightness a little bit, you can wind up with it. If you're in some unfamiliar ground, you can sometimes sort of invert the way let me see if I can, so you can sometimes invert like streams, then we'll switch to looking like ridges and vice versa. I can't really, it's so well defined here, I can't really illustrate that based on the different shading. But anyway, it just helps you to clarify your visual perspective on that. So I'm going to come back to my plan view. I can toggle that on and off. I'm going to go back to my surface, to my model, and I'm going to turn that surface off just so it's out of the way. We're back to where you've got the same thing. All right, so now here's how to navigate. There's a couple of ways, and the way you want to do it is that this icon that shows the 3D cube and the little rotation arrows around the bottom, that's the main control icon. When you do that, your cursor is going to have a certain shape and all that. So you can do, you know, you can come down here and grab these sliders on the bottom here and do all that kind of stuff. Hit your little tweaks and all of that. I'm going to go back to plan view now. That was this one. But the key to having this work so you don't have to think about all that is make sure this y-axis is locked. So if you unlock that, then when you slide this around, you see how it lets you rotate around that y-axis. But if I lock it, now when I go to, I can't move that. And so I'm only going to be able to roll around the x-axis and around the z-axis. And those are screen designations. So when you saw it spinning back and forth, that was that y-axis, the up part So my x-axis, you see, spins around the horizontal axis. So, but if this is locked, it's going to help us to navigate with these controls, and I'll show you how to do this so that it becomes second nature to you. So let's say we wanted to look at, say, up in this upper right-hand corner down the edges of that roadway. Okay, that's where we want to see, and we want to get down to it. But here's how you set any view perspective you want to set. Is if you choose the little icon, the cube and the rotation arrow, and now notice as you hover the mouse, as you come in from the side, you see it's a Z with a rotation. And then as you get close to the edge, at some point, it's going to switch into an XY. The same thing happens up and down. You see it gets off the data and it turns into a Z. You're over the data and it's an XY. Same thing on the left. Now it's not exact, okay? So it's just when you're getting proximal. So there's two different motions that happen based on what that cursor looks like. So you want to be over the drawing area so it's an XY, and then go down toward the bottom to before it switches to Z, stay somewhere in there. Now, what you want to visualize to yourself in your mind is that you're standing in your driveway and you're looking at your garage door at your house. And this is one of those solid doors that just raises up and rolls into the overhead space. It's not segmented, so you're not going to see any of that, but it's just a solid door and you're going to raise it up. So you're going to click the left mouse button and hold it down and then just push it up. Notice if I go, if I lock, let me lock that Y axis. That's why I said lock it. So notice when I push it up, and if I go back and forth, left and right, nothing really changes. But if I go up and down, it's changing. So what you want to do is roll this thing up. And if you need to let it go and go back and grab another chunk of it, you want to do that. You want to roll this thing up so that it's sort of, mostly oblique. You don't want it, edge on, but you want it to be, something like in there. Then let the mouse button up. Now, bring the cursor down to the bottom where it's a Z, and if you click and go left and right, and if you go up and down, nothing much happens, but I'm now spinning around the Z axis. And so I'm going to spin this thing around, and I'm going to line up to where I was looking at this road, and I can pan by pressing and holding the wheel and zoom in. So I'm going to line up and just sort of tweak my alignment. And then I'm going to point to it and use the wheel on the mouse and zoom in. And you can use it to pan and zoom and do, all kinds of things. So if I wanted to look, say, at that stream bed coming into this pond, I'm going to roll back out, spin it around, sort of get lined up, and then, tweak in my little perspective, then maybe come back out here and say, look at it in this regard. Maybe I want to look over here. Or if I just want to go back and let's say look at the road bed down this other edge, I can either go way back out or I can even, just come out here and hit this zoom extents, roll it up, line it up, so to get it to where I was interested in looking at, and then point to it and zoom in and out. So that lets you look at your data okay, pretty easily. If you always just keep that in mind, you want to zoom back out, hit in plan view if you need to, grab your garage door, run it up into the ceiling a little bit, spin it around to where you want to line up and look, and then roll, zoom into it and back out of it. Okay, so pretty much any way that you want to look at your data is going to be easy. And if you get sort of out of whack with it like that, just hit your plan view, reset, and go through that process again. All right, everybody see that and figure out how that behaves for you? Now, one thing that you also want to look at to help you visualize some of this elevation data is let's go to the settings tab now. And let's turn on the bounding box. Right now it says none. Let's say box only. And so this shows you an enclosing box that contains all of your data. So if you had something that was way out of whack, for instance, if I had this one, and let's put it, say, back at 500, where it's not quite zero, but it's still a bit. Then that tells me, okay, now I can see that was obvious, but sometimes it's just a point. So if you look at that bounding box, let's say you're having trouble trying to model that data, but if you look at that bounding box, that's another sort of variation on this color by elevation, where you can see the same type of thing, okay? So get familiar with those tools as you're working. And I'll set this back to 0 here. And let's see, this is supposed to re-render the drawing if necessary. Okay, that's back in the drawing. So I would have to at this point. And I think maybe if I turn that layer off, and now if I turn it back on, no, it still stays until I exit and come back in. So anyway, so if you get familiar with that, these little visual cues that can tell you that there's something going on that you need to try to resolve. And sometimes if you have that box way down, you can look in one of the corners and you can see something that might be out of whack, and you know that then get out of here, go back and fix something and then put that back to 0 or what have you. Okay. So now, if we're in our viewer, and notice that is a resizable window. I'm going to turn this box off. Just I can see this, and I get a good sense of what this ground looks like just by looking at that data. So I might say to myself, hey, that looks pretty good. I'm going to go model that by selecting all this information and seeing what it looks like. Okay. Now, let's do something else here a minute. Let's go back to the view menu and choose restore layers. I'm sorry, not restore, we froze. So we need to go view, thaw layers. So that puts those layers back on. Now I want to zoom in a little bit, and I want to go to my freeze layer by pick, and I'm going to turn off the contour elevation labels, the contour lines, and I'm also going to come over here and get these contour lines and turn them off. So now all I've got are these 3D edges and these points. Well, let's look at that in our viewer as well. So I'm going to go back to my 3D viewer, and I'm going to look at that, and I'm going to say, hey, you know what? I mean, it's not contours, but I can see that that would probably define that surface, because I've got things like, this little wall over here. I've got an actual, let me zoom out and come back around. I've got a little loading dock right in here where this is the front face of that laid back loading dock. So if I'm going to be using all of that data as brake line data, and by the way, these brake lines that are drawn in here, they have, I'm going to exit this for a minute. You see, they have individual vertices along, it's a 3D polyline. And when these triangles form, it sits at every vertex and starts building triangles, okay? So that's going to be what I can use to build this surface. And that's actually what was done. Those 3D brake lines and these points that you see here, they're too small to show up here in the CAD side of it, unless I were to change the point display. Then that's all of the data that the photogrammetry firm used to come up with the with these contour lines and labels and to deliver that as a contour map. Now, what they did was when they built that, you can see if I do, I'm going to do a real quick, let me change my layer control here. I'm going to make my boundary 10 red and heavier so that you can see it without me having to change it every time. So now if I do this, so there's the bounding area of my data that they used. But when they delivered it, I'm going to now isolate these, and I'm going to shrink wrap that again. All right, so I've got two boundaries here, and I'm going to turn all my layers back on, restore my layers. So what they did was they used all this data to model with, trimmed out to this edge, but then when they delivered the contours, they trimmed it off to the edge. So they usually go, I don't know, it's like 50 feet or something in there. Let's just do a distance, say from here across, that's 50, yeah, it's 50 feet. So what they do as a general rule of practice is they take all the data, they compile it, and then they trim it off 50 feet so that you don't have this sort of iffy data around the edges. And that's what they delivered, okay? So that's sort of setting the stage for this concept of a boundary around our data that we use to model the data with. So a couple of things on this modeling that we're going to talk about. We're going to go through these examples to build these two surfaces and see what they, what the implications are if we do or do not do certain things. So the first thing we're going to do is we're going to build an existing surface from just the contour data. So we're going to go back now and freeze by pick, and I'm going to pick the 3D lines, and I'm going to zoom in here. I can't really see. I want to get rid of those points. So if I want to see those points, let me go to settings and choose IntelliCAD settings and choose my point style. I'm going to just temporarily turn these on so I can see them. They're there. You can see them a little better. So I'm going to now freeze that layer also and pick one of those. All right. So now a lot of times what we do when we receive the base mapping from, say, an outside surveying company, but we need to build an existing ground, existing grade. We'll say, okay, they gave us the contour, so I'm going to build my surface from this contour map. Okay. And so when we do that, that is actually one of the poorest choices of source data that we can use. And we'll explore that why. We're going to go through several different variations on this. We're going to build the surface from the contours, and you'll see it's not going to give us any errors, but we're going to have some errors. And we'll see and figure out techniques of how we can control that. But in our case, we also have all those points and all those break lines. So we're going to be able to see why that is the more accurate source, and it's going to generate contours that are going to match what they delivered as part of their base mapping file. So again, if you just keep in mind that contours as a source of data to model the surface are, believe it or not, some of the worst that you can use because you don't have any break line data other than the contours themselves. But when we go back and use the actual 3D data that built the contours in the first place and ignore the contours, you're going to see that the resulting surface matches what they delivered in terms of the contours. Okay, so we'll do that. We'll pick that up after our little afternoon break. Any questions on this so far? Everybody got a sense of some things that were helpful, like in the 3D viewer?
Yeah, I think it's been good.
Anything new? Anybody bored out of their skull because you do this all the time already? Josh, how are you?
Some of it's some review, but a lot of the view control stuff in the 3D viewer was, there's some stuff I didn't know in there. So I think it's a lot of kind of tweaks on, you
Yeah,
know, a lot of my standard workflow. And yeah, any additional info has been good so far. Yeah.
good deals. All right, so yeah, and I don't want to focus too heavily on what we normally go over in the fundamentals class, but I think because of the absolute essential nature of being able to model things correctly, I think it's worth exploring the implications of what we're doing here. So we'll go through that and we'll model these in a couple of different ways and then start getting into the design aspect of it. And then tomorrow we're going to hit that part really nice and heavy where we're going to do, building pads and parking lots and roadways and all of that different stuff. Okay. So, we'll go ahead and take our 15-minute break. So we'll come back at 15 after the hour and we'll pick up from there. All right. And with that, I will pause and resume. All right, now we talked about what goes into building a surface. For instance, let's just go over here to the side for a little bit and let's off to the side. We're going to draw a 3D polyline. And if you get these options up, if you don't see this box, click O on the command line to bring the options up. And we want to prompt for the elevation or slope, okay? Everything else we'll leave unchecked. And we just say use the current drawing properties. It doesn't matter what layer we're on. So we're going to say okay. And I'm going to click a point here. And I'm going to give that a point. You see by elevation, it's asking for the next point or the elevation or interpolate. So I'm going to type E to give it the elevation. I'm going to make that elevation of 100. Okay. Now I'm going to go over here to the side and I'm going to just anywhere sort of arbitrarily pick a point over there and I'm going to call that elevation, say 105, hit enter. I'll come down here and grab one that says 103 and hit enter. And I'll come back down to here and I'm going to make that one say 97 and hit enter. I'm going to come up about halfway and make that one just 99, hit enter. And I'll come back in toward this way and make that one 101 and hit enter. And then I'm going to type C to close. I now have a three-dimensional polyline that has elevations along each vertex. I can see that by selecting it. I'll sit here in my vertex 1 and I'll step through it and you can see the elevation is going to change in my properties box as I step through those vertices. Okay. So we're going to use that to build a little mini surface to see what happens when we do some things or not. So let's go to the surface menu and choose triangulate and contour. Now, I'm going to uncheck this the triangulation file, and I'm going to draw the triangulation lines. I don't normally do that. I normally save the file. I don't bother drawing the lines in here because I can always see them in my viewer. But I'm going to do that, and I'm going to uncheck use the inclusion exclusion areas. And when that is done, I'm going to say my reduction for my perimeter is going to be none, just show what this means. And I'll say my erase previous, I'm going to say all contour entities. So anything that we do and redo, it's going to clean up the stage for us. And I'm going to ignore 0 elevations. Again, that's from my default. And uncheck anything else down below. And then on the contour tab, let's check to draw the contours. And we'll contour by interval. Let's make that a, over here on the right, we're going to make that contour interval 1. We will draw the index contours. We'll make that a contour interval of 5, and those things are paired together. So if I were to make this, say, 2, I tab out of it. You see how that makes that 5. So I'm going to make that 1 and 5. And I'll just turn my contour smoothing off. I'll leave that set to no smoothing. I'll go to labels. I'll label the contours again, taking all of this layer name up here by default. And I'm going to check on to label the index only and hide the drawing under. Align it with the contour on the real Z. And my label intervals, I'm just going to say 1 per contour. I'll look at my selection tab, make sure I don't have any filters in place because I want to use everything that I select. All right. And so now I'm going to say OK. And it wants me to select the points and break lines that I want to triangulate. Well, there's what I'm going to use is just that figure that I drew. And I'll say OK. And lo and behold, it has created this set of triangles. I've got, if you notice, let me go back to this original feature that I had and make it so we can see it. Let me get the color here is yellow. All right, so there was my original feature. And you can see the triangle lines. I'll select similar and I'll bring them up to the front. All right, so these are the triangles that got formed. So there's one in here, there's one out here, there's one all the way like that, there's one all the way like that, and then one up here in this corner. So what it did, if you can imagine, let's start up here in the upper right. It stood on that corner of that original yellow line, and it looked all around itself in 360 degrees, looking at the data we selected, which was the line itself. We didn't select any of this other data. So it looked around itself and it said, okay, where can I find something else? And it finds this point over here next to it. It finds this point down here next to it. So it draws that line and it draws that line. And it also looks around and it sees this corner coming in down here. So it drew that line. And it could have, if you see this, comes up here, hits this point, comes back down. It could have maybe gone from up here to all the way to down here instead of catching that point. But without any controls, that's what it did. And you can see the contouring, the red and the white are the contour lines. The purple lines are the triangles, okay? Now, what's going on right here? What happens in this area? Do we know anything about the ground in that area? So we do not, so we would normally have to get rid of those triangles. Now, how do we do that? Is we need to establish a boundary for this. So to do that, we can either shrink wrap this data, which we draw a bounding polyline around it, and that's with that draw shrink wrap entities. And you can choose to allow it to go across gaps. In our case, we have a closed figure, so we don't need it. It could be bounded only. It doesn't matter. And you can choose a 2D or 3D. Again, it doesn't matter as a boundary. So we could have done that. We could also have just simply used itself as its own boundary. But we can, and I'm going to erase by layer. I'll clear, I'll select from the screen. So I'm going to select these layers, come back to our original. Now, what can we do on the automatic side of things? In fact, let me bring this in a little bit. Maybe the triangle now might form all the way down that long. So if we repeat the command, draw or surface menu, triangulate and contour. Now, one of the things we said was if we have a drawn boundary already drawn, we can use it. But even if we're not, if we're unchecked, use inclusion and exclusion, we have this number right here, shrink wrap perimeter reduction. If we pull that down and choose anything other than none, then in this case, you won't see much difference, but it's just a matter of how tightly it goes in and out. So if I say medium, and I can go to setup tab, and I can put this, make it a 2D, and we'll draw it, and we'll put it on that boundary 10 layer. So I'm going to say okay. And leaving everything else the same, I'll say okay. I'll select our data, and there it goes. Now look what happened. The red line now didn't really come in and bring that, select that, but it didn't come in and cut that into where it's supposed to go. So that's a case of letting it automatically happen, and it wasn't enough to reduce it. If we, you can see that I'm going to back out here a little bit just to show you the difference in the way, if this is doing it this way, I'll do a high perimeter reduction. Now watch what happens when I select all of this stuff. You see how sort of, now there's a point out here apparently. It's a little bitty polyline there, and I'll get rid of that. And I'm just going to get rid of a couple of these vertices. All right, so there we go. So that's what happens is it comes in here and it jumps down here and follows that around, and it's sort of, it's jumping in, it's tightening it up as much as it can because it's got a high reduction. Now, if in the contrast, if I do that same thing, shrink wrap polylines, and instead of a high reduction, let's do a low reduction. And we're going to select the same data. And you see it still jumps in some, but it's not as tight. See, it didn't come all the way in like it did up here. It just sort of leaves some of those in place. So it's a little bit more relaxed. On the contrast, the way we did it before when we said none, you can see when this happens. Now, again, what I'm illustrating is doing this manually. So that goes to the farthermost points and then goes all the way up to the farthermost point. So it doesn't reduce any of those resulting triangles. As a matter of fact, the way this command works to draw this boundary is it actually computes the triangles. It's just like it's doing a triangulating contour, and then it's throwing away those edge triangles based on that reduction amount, and then leaving you just with this drawn polyline. Now you can do, any kind of manipulation that you want to that polyline, and then use it once you have that polyline drawn. And let's say we got rid of, say, some of these, once that's drawn, when you do the triangulating contour command, again, triangulating contour, you would just check this. And then when you're prompted to select your data, it's going to ask you for that data. Okay. So now back to our example. If we erase by layer, and I need to select, and I need to make sure I get that included. So if we, Let's see, and bring this in a little further. Maybe we can get it to stipulate that. So if we go back and run that command again, triangulate and contour, we're not going to use it, but we're going to let the shrink wrap reduction be high instead of medium. And we say, okay, and we say this selection, it's still not. Try that one more time here. Let's go to our setup and let's make that a, yeah, it's not, it's not honoring that in terms of this bounded figure. So that's okay. Let's do it this way. If we have a gap there, so I'm going to delete a polyline segment. I'm going to get rid of this polyline segment. And let's see if that then, because there's now a gap in it, we'll see if that will change. So I'm going to triangulate and contour again. We'll leave it to a high. We'll say okay. We'll select our polyline here. No, it's still. Well, it's an interesting way of, let's see if we can have it use itself. Yeah, that managed to do it. So it trimmed it off because I told it to use an inclusion boundary and I selected it as an inclusion boundary. Okay. So that now trimmed that off, even though before it filled this in because it was going around that figure and it allowed that triangle to get built from this point up to this point. Okay, so now the triangles are down here. I've got 1, 2, 3, 4 triangles, and it generates my contours as you see them there as well. Now, a couple of things that we can do beyond that. Let's go back to triangulate and contour. And this time, instead of, we'll go ahead and keep that and we'll just use itself. But let's densify the break lines. And I'm going to densify that every 5 feet. So I'm going to check on densify and use every 5 feet. Now, what this does is the same effect, although it does it only in memory. But I've got another command on the edit polylines that under the edit menu, under the polyline utilities, it says densify the polylines, and it writes in additional vertices all along that figure every 5 feet. Now, if I do that as a command first, then that line is always densified. If I do it here inside the command dialog, it only does it in memory, but then throws away the vertices. You'll see what I mean in just a minute. So let's say, okay, we're going to read the prompts. They're slightly different now. It says select the inclusion perimeter. So that's that one. I'm finished selecting inclusion perimeter. So I hit enter. Now select any exclusion polylines. I don't have any, so I'm going to hit enter for none. And now select the data. Well, there's that original. Now, notice the number of triangles that you get because it went every 5 feet and put in a vertex. So each one of those could find those other triangles. And you see what it does down here because it's going long back and forth across this way. I get these little jigger jagger type of contours, which I'm sure you've probably seen before. A lot of people will fix that by swapping triangle edges and going every other edge to swap, and it sort of smooths that out, but that's not the better way to do that. Would be to add some additional data in here so that these triangles aren't, you know, long and skinny. Okay, so you could do that by, let's erase by layer again and just hit enter. So we could say draw another 3D polyline. And we're going to just go from the midpoint of there, accept its elevation, go to the midpoint here, accept its elevation. And now, when we triangulate and contour again, do everything else the same. There's my inclusion, no exclusion. I now have this and this. And so now you see I get a different formation of triangles because I now have a break line that it can't go across. Now, it managed to mangle this one up pretty bad as well. Okay, but you can see the difference here is that when this polyline, you see the grips that show up, I still only have 1, 2, 3, 4, 5, 6 vertices. But in memory, it went through and densified that so that every point along those would be as if I had done this, edit polyline utilities, densify polyline vertices. I'm going to select that yellow polyline. Let me see. I'm going to go every 5 feet. So it now added 124 points. And so when I select that polyline, you see all the vertices that show up, and look where those triangle points happen to hit. So that was exactly the same thing, as that it internally densified. But now, if I go through and do this to all my data, and I want to be able to sort of snap to midpoints and endpoints, it's going to look at that on a segment by segment basis. Plus, it's going to add to my file size. So I don't want to be doing that operation of densifying, except inside the command, and let it do it internal if I need to do it that way. Okay. So I'm going to go out here and erase that, and let's look at what's going on with our data. So let's go to the triangulate and contour command. Let's go to the surface menu, triangulate and contour. Now this time, we're going to write the file. So I'm going to check on up here to write the file. I'm going to select. Here we go with that file open dialog lag. It's something that happens when I'm running under Zoom and I don't know how to resolve it. And it's not constant. It's only every now and then. Like usually I have to kill the Zoom session, restart it, and come back in. But come on. Finally. Now let's go to my current class folder, and I'm going to call this file. Am I in the right one? Oh, 313. Yeah. I'm going to click up here in my file name, and I'm going to call this EG dash CTRS. So I'm going to be an existing ground from contours. Now I'm going to uncheck to draw the triangulation lines. I don't care to see those right now. I'm just going to look at this stuff inside the surface viewer. And I'm going to uncheck to use the inclusion exclusion areas. And my shrink wrap perimeter reduction, I'm going to set to none, just so you can see what happens without it again. And I'm going to uncheck densify break lines because they're about all I really need. I'm going to go to my labels on my contours and just turn them off, but I do want to see them. And I'm going to set these to a 2-foot interval. to match what I've got in my data set down here. I think there are two, so there's, nope, they're ones, sorry, put that back to one. And I'll say, okay. And now it wants me to select the points and the break lines to triangulate. Well, that's all of this. So I'll select that, hit enter. And now you can see my contours laid over top of theirs, mostly in places like this. I'm missing a couple spots like right in there and right down those little tips. But you see, I've got all of these out in here because I didn't shrink wrap, right? I didn't let it, or I said no reduction. Okay. Now, let's go back and repeat that again. So I'm going to go to surface, triangulate, and contour. And we'll leave everything set the same, except I'm going to make sure that this erase previous contour entities is set to all, so I don't have to erase them first. And I'm going to change that shrink wrap reduction from none to medium, which is a good example. So I'll say, okay, yes, grab my data and let it go. And now it drew that, but you can see up here how it went chopped into the ends of those. You see the contour itself, which is, here's for instance one, here's one. So it goes out to those ends of those contours, but instead of going across that gap, it came in because I had it on a medium reduction. If I repeat it again and change it to a high or no, not a high reduction, but a low reduction, it's going to keep some of those. There you see how it sort of jumped across those apps and made it a little nicer, but it also sort of, you know, gave me stuff out here that I don't really know about. Okay. And if I if I start to compare some triangles, or contour lines rather, I can see, well, I'm, missing a couple of these little peak points. But where it's especially telling is, let's zoom in over here on the road edges. All right, so right here, for instance, is one of the original contour lines that they gave us. And you see the grips and follow it around, and it comes up here and comes up that sidewalk face, that curb face, and around accordingly. But here's my contour line. So what happened in there, do you think? Is when it's reading this contour data, that's what I had to start with. It's coming along at every point along here, and it's starting to look around itself and find other points. Well, in this case, it comes up to right in here, sits on that point, and instead of going to this point, to this point, to this point, it created that triangle edge first. So it jumped across there. Same thing it did over here on this one, is it jumped across there. And so then it had these other triangles were now set to come back among itself this direction, but it wasn't enough to trigger a contour to be drawn to see something missing in between there. But look right in here. This line, let me give you some line weight on that to see it a little better, maybe even more than that. All right, so there's the original contour line. And here's the contour line that I'm left with. Let's make that yellow, and we'll bring it up a little heavier too. All right, so this is the line that it's reading from the data. The yellow line is the resulting drawn contour from the model. So as it's stepping its way along here and it gets up to this endpoint here and it's looking around itself, it looks all the way over here and sees that contour and creates that as a contour edge. Well, that means that this line or this peak up here can't look all the way down here and find the peak of this contour line, because this line is now in the way, because these triangles have formed first. Now, what do you know about the triangles that form in this region here? What is their elevation? Isn't it flat? It's the same elevation as this contour line. because it goes from this elevation of 1309 to 1309. Here's 1309. Here's 1309. So it assumes everything in between all of that is all set at elevation 1309. It makes a flat triangle. Okay, when really we know that if we draw that line the way it's supposed to be, it should go like that. And you start here at 1309, and you come down here to 1308. And so about halfway in between it should be 1308 and a half. But it's not, it's 1308, and it immediately at this yellow line became 1309 and stayed 1309 all the way up to this point. So what the effect of all that is that when we start to look at the surface that formed there, we have those flat triangles. In fact, let's take a look at that. Let's go back to our profile menu and quick profile. And this time let's choose a surface file. And if you may or may not have one or two names listed here, they're left over from last time. So if you do have one, we don't need a second one. So just hit the second button and choose cancel. That'll clear it. And so I'm going to go to the first button and wait on my lag. Oh, good heavens. And there's the file that I just made, this EG-contours. So that's what I'm going to use. I'm going to say, okay, and I'm going to now go from, say, here, let's go all the way down to, say, here. And there you can see what should be, because I went down that line of what should be that ditch line, excuse me, and you can see where it's, what's going on in here. So if I look up here in plan view, now follow the tracer in the profile view, I see I'm flat till I hit right there, and I drop down immediately, and I come down, it sort of squeaks through a little bit. Then I get down down in this region, and I'm flat across there again. Then it drops immediately till it's flat again, drops immediately till it's flat again. So you see what's happening is every time it hit those little sharp indented areas, it was flat. Okay. I'll show you another little thing about this quick profile. When you are in surface view, you have this button over here called adjust alignment. And so you can now take that and click near one of the ends. And as you drag things around, it's going to, and you have to, every little adjustment that you make, you don't have to snap to it. Just if you pick nearer the end, you're going to anchor the other end. If you pick nearer the middle, you can now use that to notice it's in real time, it's reading that surface. So it's a great little way to read things. And if I go up here and I look at this area in here, I know, well, I've got some issues in there because I don't have any existing contours out in here. I was missing that data. They trimmed off their contours, but I didn't have any other data. So it filled in the blanks with some incorrect information, but it gave me no errors. So therefore, I would be in my blitheful ignorance remiss if I were to use that resulting surface for anything. All right, so that's just another way of looking at that. Now, how can we fix that? Well, much like we did with the shrink wrap, we've got some controls inside. So if I go back to surface, triangulate and contour, and now this time we'll keep the file name the same so we can look at it again. Oh, one other thing before. I want to show you in the surface file viewer. Oh crap, I'm gonna wait on the file name. I'm gonna do something, I'm gonna try something here to fix it in just a second. We'll wait. Just a minute, I wanna get this. All right, so I want to look at my EG contours surface. And we say, congratulations, we built a surface. Looks like we got a surface. Well, okay, that's all well and good, except let's take a real kind of closer look at this. And you see all those little flattened areas along that ditch line? All right, so what would happen, or what would I need to do to fix that? I'm going to go out here and I'm going to select these lines. Now, those lines happen to be at, oh crap, they're at zero elevation. Mm, let me, is that topo break line layer? Let me turn that back on. All right, so now if I were to repeat cube surface, come on. And this time I'm going to now add in just those two little, or actually three. That, well, really it's only the one, so I don't even need this one. Well, if I get it, I get it. No big deal. All right, so now what do I need to consider doing perhaps? And let's look at our, there's our resulting line here. And let's make that visible. A little bit better, so it's red. All right, so if that was the actual ditch line, and you can see where it heads into it, okay, here, and we can see there it is running down, but you see how that triangle formed? If I display my triangle edges, you see how this triangle formed. Let me get the pointer so you can see it a little better. See this triangle that formed across right here? If that edge had been drawn in there beforehand, it would have prevented this point from looking across that edge and finding that point and making that triangle look like that, which makes it look flat. So I really needed to have made that a break line as it travels down that road. That's why those white sort of random looking lines on that V-topo break line layer would be so important to use in modeling this surface. I'm gonna come back here and turn these triangle edges off. Okay, so, and you can do a number of things. Because I'm in the surface viewer, I can edit. So I can come down here, as long as I've got my pointer selected, I can choose to add a break line, for instance. And so I'm going to turn these off, and I'm going to say, I'm going to add a break line from, and you'll see the triangles react accordingly. So I'm going to go from right here 2 over to here. If I can. So you see what I'm doing is here is I'm adding these break lines in between. Here's another place where I need to add it. And so you see how it reforms the triangle so that they don't cross the break line? They now make it line up along the break line. And you'd have to do that, all the way down. I mean, you could do it, say, from a given point to a given point, but you're not going to be able to follow. Yeah, see, it doesn't follow the doesn't follow those edges. All right, so you could do it that way, and in which case now you see where I've added those, it smoothed them out, but I would have to do that all the way down, all throughout my drawing. And I know I'm not going to save those changes. Or if I did it this way, if I said triangulate and contour again, leaving everything as it was. Okay, to overwrite the no. Yes, it's okay. And I want to select, just say all. So the boundary is going to be a little different this time. Oops. Yeah, so I'll say all. Up. That's actually not what I meant to do. Hang on. To illustrate this point. All right, let me erase by layer again. And this one, I'm going to change that to just be on layer 0. And now I'm going to freeze these others. So now, if I triangulate and contour, say okay, yes, okay, select all my data. And I'm going to come back to that another day. We'll talk about that in a minute. So now, as it's drawn my contours, you see what it's done is it has honored that one break line that I had there. That was that 3D polyline. We'll again make it so you can see it here. Let's see. So I now had placed that in there as a break line, although I still see it didn't. I think it kept it. There we go. Now, I triangulate contour. It kept that previously drawn contour line, which wasn't. That's why I was getting those crossings. No, and still had a issue in there, but anyway. So now as I look down the line, I've got, except for the few cases, it still jumped across that line. I think that's where that line was outside of that peak. I don't know why. Let's see, I've got 2 polylines there. This one. It still formed a contour line across it. But if I look at my surface now, because I had that one little edge drawn, we wait for the file name lag. Now, let's look at the difference here along that edge. So see, with the exception of, there's one little spot in there and a spot in here, and I don't know exactly, I may have missed, because I only put that one line in there, and it may not have gone all the way down. There was something about it that allowed those, but you can see it took by far most of those, whereas you can see down here below, I've got all those flats. Over here on this side, I've got all these flats, but right here where I honored that break line, I kept those from happening, okay? So that's one way to do that, is if you had that original data, which we do, and we'll build our final surface out of it, but so you need to be able to include all of that stuff in as our source data, or you have to go back here and draw those break lines all the way down through all of these different areas. And you can do that, and it takes, you'd be spending a day trying to prepare your data just to build the surface. All right, so Carlson has given us yet another tool, and we're going to do it with another pass through the triangulate and contour program. And this time we're going to look down here at the bottom, and it says, there's two sections at the bottom. It says adjustments for dense existing ground. So you can simplify it if you got too much data. Never really had to do that. But above there is a block that says adjustments for source data of contours. Remember I told you that was one of the worst places that you could get your source data? But one of which that you want to do here is to minimize those flat triangles. So it's going to look at those flat triangles that it formed and try to minimize the number it's going to create and come up with an alternate arrangement of triangles in those areas where you have flat triangles. So if you do this, go back and do it one more time, grab our data, up it runs, and now we're going to do that one more time if you can wait on the lag. Okay. So now, just like we saw by adding the break line, you can see it has minimized the flats all along this edge over here. Now we still have some over here because we really needed to have those break lines. There's a break line right in there. Let's not let me do that one. Let's do one from here to here. And then we'll do, say, from here to here, and from here to here, here to here. So you see, this is sort of a little brute force on some triangle edits, which I don't really need to be doing. I need to go back out into my data and put those in as my original data. See, there's a case where it won't let me add that. I want to be able to go from there to there. And it tells me it's unable for whatever reason. But you see, what you would have to do is to just walk your way around the site and clean it all up in this similar type fashion, which is not really, a very efficient process either. We had to go all around our edges and do all that fixing. So but we at least have a little bit of something going on that we can, um, eliminate those flats. And we still have this problem over here along this edge that, let's take a look one last time. And we're going to, I meant to say no, sorry. By the way, while we're waiting on that, down there at the bottom, you've got these clipping controls. Uh, Play around with those when you get a chance. That lets you sort of clip out what you're looking at here in case you've got something in the way that you want to look through. So you can sort of clip that down. So now I'm going to cancel that. Now, I'll clear all this out again. I see right in here was where all of that mess was, this loading dock, because the contours come over here and die. They stop, but it's jumping up to this next contour because that's all it knows. It doesn't know about this stuff. So let's turn all our layers on. So we're going to go to our view menu and choose thaw/on all layers. So we've got all the layers on now, and now we're going to freeze, go to view, freeze layer by pick, and we're going to jump in here and scroll down and get our contour label or contour, minor contours, and go over here and grab the obscured or the dashed line contours as well. So now the only thing that we have in 3D are these break lines and points. Okay, now you're going to see something amazing here when this happens, is we're going to triangulate and contour, and we're going to change the file name this time to EG. Instead of CTRS, we're going to say EG BKLNs. So existing ground from break lines instead of existing ground from contour. So if we ever have that situation, we're going to, now I'm also using those points that I thought as well. I no longer need to worry about this minimized flats because I'm not using contour data. So I'll uncheck that. I'll grab all my data. Off it goes. Now I do have a couple of errors that popped up, and I'm going to show them to you here while we're in this process. Because I used these break lines, used all the break line data. I've got three potential problems for errors in surface modeling. If I look at my settings button, you can see what those are. I've got crossing break lines or crossing barriers. I've got T intersections, or I've got vertical edges. And right here, I get crossings and verticals. I don't have any T intersections. And what that means is that, and I've given it a tolerance value of 1,000th, that if they differ by more than that, that's going to be where it shows up in my report. And I can use this report. So I see these when they're collapsed. I've got 3 crossings, 2 verticals. If I go to crossing, if I select one, that tells me that my vertical difference is in parentheses, and it tells me again on the bottom, Z diff, and it shows me where it is, or I can zoom to it, hit zoom to, and then I can zoom in, and it just keeps zooming in. You see the little marker, and it happens to be all down here around this little head wall. So if I were to look at what's going on there, sort of, you know what, I need to do that as probably a 3D viewer. But in any case, what's happened is when the photogrammetrists compiled this, they had one edge is supposed to be the bottom line of this head wall, and this other line to be the top edge, and you can see how they cross over each other. So they were just a little sloppy when they did their work. Their software must, it doesn't flag that as an error necessarily, it just goes on about it. So I could go to, and would, if I got these errors, I would zoom in here and try to fix those errors and try to, uncross those lines. Like maybe I would take this and put it, on the outside of that, and then go to my next spot. And there's a spot down there, a crossing brake line. I zoom in several layers, and what's happened is that I've got this one particular edge of the road that comes down and meets this road or entrance or whatever that happens to be. That brake line crosses over this edge just a little bit. And so I would just trim that back, and I've also got a couple of vertical edges, and you see they're pretty small. There's a 0.04 and a 0.01. So you would navigate your way around there and fix all those errors. Okay, so I'm just going to take that one. And actually, if you don't fix them, you're going to just take whatever it chose when it built it. It decided to use one or the other. So I now resolved that one thing. If I go back now and rerun the command, you should see that head wall error goes away, I think. I've got one. Yeah, I've got a crossing up there, and I've got these two vertical edges. So I'm within, I'm less than a tenth in each case. So I'm going to sort of get out of that. Now, let's take a look at that resulting surface, and you'll see the difference. Because remember those contours up around that loading dock that were all spread all over the place, and that surface file showed that as well, with that little long ramp that was up in this area right in here. So now we're going to take a look at that EG from brake lines, and you'll see it's nicely cut out there. I've got these sidewalk edges and retaining walls, all of my curb lines, everything that my contour modeling didn't pick up any of that kind of detail, because I wasn't using those elevated lines. I was only using the contours. So if I go and add, oh, come on. I go and add this surface, which was my existing contours. Now let's turn off the existing. So here's my original, here's my new and improved. If I turn it off and turn the existing on, you can see all this mess in here. And you notice there's no definition on the curbs like you see here. See, all of that's just missing. And that's why we need those edges. And if you look at now the edges down the roadway, see, that's nice all the way down. This edge over on this side is also, all the way down. You see there's a little walking flat area there. There's a little curb, and then it's just some flat ground. But they captured that in the aerial imagery, in the photogrammetry, and gave us those brake lines. And that's what we use to generate that surface that we can build with. Now, to do one last little visual comparison is, let's freeze by pick, and let's pick one of those brake lines. So now we've got our drawn contours, which are the red and white ones, over top of their sort of greenish looking ones. And you're going to be hard pressed to find places where they don't exactly agree. I'm sure there are some. This is an outline. It's not a contour line. That is zero elevation. It's just outlining this brush pile. And you see, I'm going to make sure that I do have. Let me turn on all of them. And now let me freeze off the break line layer. There we go. I was noticing I should have had so here you see a little bit of disagreement, but even all the way up these areas in here, you can see where those contours are now, our contour lines get modeled pretty nicely, although I don't. Must have changed something in that. I think I must have changed that one edge because it sort of screwed up that corner. But you can see here, as even if I'm coming down here, I've got a little bit of a jiggle jaggle right there, a little bit of a miss right in there. But everything else, you see, I know I used to have those flats that cut across in here, but because I used their data, their break line data, I got all those. And even over here on the contours, see, my contours drew along the face of that wall. They just had theirs clipped out for clarity. But I've also got my contours. They hit the face of the curb. They walk up the face of the curb, and that's a triangular curb, a wedge curb. It's not a square curb. And so hopefully you can see the difference in over here's, for instance, that, those are those retaining walls and curb islands and all that kind of stuff that you see our modeling picked up. Okay, there's another one of those little loading dock areas, retaining walls. All right, so I hope you can get a sense of the difference and why contours are a bad source of existing data. And I will say it with this one caveat is that sometimes that's all you have. And so you use it. And sometimes you can get away with not modeling all those break lines down the curb lines. If what you're doing is like a county-wide watershed drainage study, then you don't really need to worry about those flats are going to sort of average themselves out. But if you're doing something like preparing a surface to go on a bulldozer for machine control, you darn well better get those edges, the precision that you need, because that dozer doesn't know how to do anything but what is loaded onto it. So in that case, you want to make sure that you add those things to it. Now, here's what I'd like to do in just a few minutes. I'm going to say pause the recording one more